Dear students, welcome to ace.online, digital platform of ACE Engineering Academy. This is Dr. G. Balaraju, Professor of Mechanical Engineering. In the present video session, we would like to present the detailed solutions for GATE 2022 Mechanical Engineering Forenoon session. Of course, we received questions from various channels, of course students only, and all questions are memory based. That's why we are not sure about the exact solutions. But however, so our objective is to assess the level of question papers, the level of questions. And everyone has some curiosity, whether the paper is easy, moderate or tough. As a matter of clarification, so we collected feedback from various students. So most of the students expressed that the question paper is moderate, not so difficult, and moreover no need to worry. If the question paper is too tough, it is tough to all. If it is very easy, easy to all. Since GATE examination is a competitive examination and relative performance, so there is no need to bother about whether the question paper is very tough or easy like that. The only thing is you can assess yourself how you have performed well, whether you have performed well or not. And here I am trying to give a slide like comparison how we had a questions. Like if you see the questions, most of the questions like a frequent asked list only. Like we had a questions from well-known areas. There was no single question from untapped areas. So if you had general preparation, if you cover all subjects, of course you can perform well. Just you can go to this particular slide, like 2021 and 2020, just I am comparing. In 2022-21, so more or less same only. Okay, slight variation. So this time we had many questions in heat transfer and strength of metals, less number of questions. Of course, it's only based on students' database. Like we collected questions from only students. We are not sure about exact number. And many students expressed that there are 5 to 6 questions like MSQ type. We are not sure about the number. So there are 5 to 6 questions related to MSQ. And NEAT type 20 to 24, we are not sure about the number also. And the remaining questions are multiple choice. And coming to the weightage, as usual, so we have 3 streams: design, production and thermal. From each stream we had around 24 to 25 marks, and in aptitude 15 marks, mathematics so 12 to 13 marks. And so without wasting the time, just let us begin the solutions. So whatever we had questions, we are giving the solutions. I am not sure about the accuracy, since we collected questions from students like memory based questions only. Just only for idea's sake we are presenting the solutions. Okay, just let us begin the session with the aptitude. So my faculty, Mr. Hemant, is going to start the solutions for aptitude.
Hello my dear friends. Let us go ahead with the aptitude questions. We have around 6 questions collected. Okay, we know 10 questions from verbal ability and aptitude together. Okay, we collected around 6 questions. Okay, let's go ahead with the questions, my dear friends. Yes, see the first question based on averages, very simple question they given. We know average is nothing but sum of terms divided by number of terms. Here average of MNS, NSP given and the value of P is given. You have to calculate M is what percentage of P, my dear friends, right? So sum of terms, we can consider sum of terms is nothing but equal to average into number of terms, my dear friends. Using this simple point you can solve this question. If you understand this point here, this question is done. Average is sum of terms by number of terms. From that we can write sum equal to average into number of terms. Here average of MNS is 4000. Using this formula, M plus N plus S, sum of these terms is nothing but average into number of how many? 3, right? So average is 4000 given, we can write 4000 into 3. Similarly, if you apply for second data, my dear friends, NSP average is given as 5000. As these 3 values we should do into 3, right? Now if you observe these 2 equations, except N and S, okay, N and S is common, M and P are the different, right? Take difference between these 2 equations, NS will get cancelled. You can find P minus M is nothing but 5000, 4000, difference 1000 into 3, we will get 3000, my dear friends, right? So P minus M is nothing but 3000. Here in question they are given P value, we can find M value from that. Yes, P is 6000 given, we know P minus M is 3000. Substitute P value and obtain M value, my dear friends. M is nothing but 3000 from the data. Okay, from the previous question, if you just go ahead, P is 6000. Using this equation, substitute P value, we got M is nothing but 3000. Right now, what is the question? M is what percent of P? X is what percent of Y? M is what percent of P? So M by P into 100, my dear friends. As it is half, many of you without using this formula, 3000, 6000, 3000 is half of 6000, directly we can claim 50%, right? So you can just mention they're asking M is what percent of P. See this time what they did, averages along with some other combination. See averages with percentage. There is other question, time and distance with percentage combination they are giving. Instead of asking questions from percentage directly, they are using these combinations. As we have less number of questions and more topics to involve, they integrated 2 or 3 topics combined in one question, my dear friends. Hope you understand this first question, very easy one related to averages. Let's go ahead with the next question, my dear friends. Yeah, see this question is related to time and distance. Very basic question I can say, but they involved at the end again using percentage. Time and distance along with percentage combination they given the question, my dear friends. See this question, you have to travel 80 kilometers in 6 hours. Certain distance is traveled with 10 kilometer per hour, okay, maybe by walking, okay, remaining distance with 18 kilometer by cycling. Okay, they didn't mention, we can consider like that, okay, some distance with 10 kilometer per hour, remaining distance with 18 kilometer per hour. Now what they are asking, my dear friends, how much percentage of distance is covered at the rate of 10 kilometer per hour? Among 80 kilometers, a part is covered with speed of 10 kilometer per hour, remaining with 18, right? How much distance out of the total is 80, among 80 how much distance, that in terms of percentage they are asking. See this question, my dear friends, very basic. You have total 80 kilometers to cover in 6 hours, right? Okay, a part of this with 10 kilometer per hour speed, remaining distance at 18 kilometer per hour speed. Total 6 hours, I can consider this 10 kilometer per hour for t hours, total 6 hours they mention. Remaining distance with 6 minus t hours, total 6 hours, right? We don't know how much time traveled at 10 kilometer per hour, how much time with 18 kilometer per hour, we don't know the timing. You can split distance 80 as x and 80 minus x, or you can split the timing, 6 hours they mention. So t hours for this, remaining time for this. Now we know distance is speed into time, distance 80 kilometers, speed is 10 kilometer per hour for t hours means 10t, speed into time. Next, speed into time, 18 into 6 minus t, my dear friends. Now here you can find t value. Do the smart calculations, always don't use pen and paper for more time. You just try to do calculations. Yes, sir, 18 into 6, 108, here 80. 1 or 2 steps you should do it on your mind. Don't do all 10 steps in your mind. To few steps you have to do it on your mind, and few steps you can write on paper. Okay, so yeah, 108 and here 80, 28 is the difference. 10t and 18t, difference is 80. So guys, if you calculate, t is nothing but 3.5 hours. T is nothing but 3.5 hours from this calculation. Means how much distance you travel with 10 km per hour, you travel 3.5 hours, right? 10 km per hour means 35 kilometers you travel with 10 km per hour, remaining 45 kilometers with 18 km per hour, my dear friends. Question is, what percentage of distance you travel at 10 km per hour? 35 out of total 80, that percentage you have to calculate, my dear friends. 35 out of 80 into 100. This is what they are asking. What percentage out of the total you travel? Yeah, this is 24 times, 25 times. It's nothing but 175 divided by 4. We can claim this as 45.75%, right? You just see this, my dear friends. Yes, if you just divide, okay, 4 16, still 15 is there. One moment, yeah, 43.75, right? 43.75% is the answer. Okay, here they are asking in terms of percentage. Generally they will ask what distance with 10 km per hour, what distance with 18. If that is the case, we can use option verification. So that's why they converted this question in terms of percentage, my dear friends. Right. See the next question. Yeah, this is related to, you can see from last 2 years, they are focusing more on syllogism concept, okay, mensuration, area and volumes, perimeter related. This is the question related to area, my dear friends. See the question, in a unit square, rhombus is formed by joining the midpoints of the square, and circle is inscribed in the rhombus. The diameter of the circle is what? So guys, if you can draw the diagram perfectly, okay, you can done with the question almost. This is the 2 marks question, we can say. Let's see the question, my dear friends. You have a unit square, okay. By joining the midpoints, similar to this question, you can find in GATE 2021 as well. Okay, similar to this. Now here you join the midpoints, fine, good, a rhombus is formed. Then what they mentioned, my dear friends, in the question, a circle is drawn inside the rhombus. You have to find the diameter of the circle. Yeah, this is, you can see here, a circle is inscribed in the rhombus, means circle is drawn inside the rhombus. Yeah, suppose this is the circle, we draw inside this. Assume this is like a circle, my dear friends. If diagram is not perfectly suitable also, you just consider, okay. Now here, consider this is like a circle, okay, inscribed in the rhombus. Now what they are asking, diameter. Focus here, my dear friends. This diameter is nothing but equal to, if you observe the diagram properly, this diameter of circle is nothing but equal to side of rhombus. That's what the conclusion from the diagram we can get. Yeah, diameter of the circle is nothing but equal to side of the rhombus. So that's the point, my dear friends. Diameter of circle is nothing but equal, diameter of circle is nothing but equal to side of rhombus. You can see side of the rhombus and diameter of this circle both are same. Now you have to find side of the rhombus. How to find? So they mentioned in the first line, it is a unit square. So 1 is the side of the square. This is half, my dear friends. From here to here, I can consider this is 1 by 2. From here to here, it's 1 by 2. Right now, it's like a right angle triangle we got. This is the side of rhombus actually. This is 1 by 2 and 1 by 2. If you find this one, this is what they are asking. Side of the rhombus, nothing but equal to diameter of circle. Using Pythagoras theorem, my dear friends, you can find root of 1 by 2 square. Okay, in the sense 1 by 4, 1 by 4. Finally, you will get root 1 by 2 or 1 by root 2. Okay. They give the option as 1 by root 2, 2 root 2 like that. Okay, you have an option. It is option or MCQ question only, where you will get 1 by root 2. Main point is, from the diagram, what you have to, diagram is not given. You should understand the data, draw the diagram, you should understand the point that diameter of circle is nothing but equal to side of the rhombus. If you conclude that, then process is very easy to do this question, my dear friends. 2 marks question. Okay. See the next one. This is very important, my dear friends, where many of you are confused. Syllogism concept, okay, where they given the statement, all teachers are professors, no professors are males, some males are engineers. First, what we should do, we should draw diagrams, all possible diagrams with respect to given statements. What is the given statement? All teachers are professors, okay, no professors are male, okay, professors and males, no professors are male. Some males are engineers, yeah, this is one possibility. Some males are engineers, yeah, some part of males are engineers, that's one possibility. The other possibility, all teachers are professors, no professors are males, some males are engineers, okay, we can draw like this also. Still there are few more diagrams possible, okay, with respect to given data or given statements. Draw all possible diagrams which is satisfying the statement. Now you go through the first diagram, my dear friends. As per the first diagram, what is the conclusion one? No engineer is a professor. Yes, engineer, professor not connected. First conclusion is true. Let it be. What about second conclusion? Some engineers are professors. No, it's not connected. Second conclusion is wrong. Okay, fine. What about third conclusion? No male is a teacher. Yeah, male and teacher are not connected. Third also correct. Fine, up to this, okay. See the second diagram. What about second diagrams? And go with the conclusion. Conclusion, no engineer is a professor. No, engineers and professors are connected. Conclusion one fail here. Some engineers are professors is the second conclusion. It is true. Third conclusion, no male is a teacher. It is also correct here, my dear friends. No male is a teacher. Yeah, third one also correct. Now here, very, very important thing. You just observe. Third conclusion is true in both diagrams. Yeah, conclusion 3 is okay. Very important regarding 1 and 2. Here either 1 or 2. Don't say first one wrong, second one wrong. First one is correct here. Either or means what? Either or means if first one is true, second one wrong. If second one is true, first one wrong. Now you observe, first conclusion is true here, second one wrong. Whereas in the other diagram, second one correct, first one wrong. Either 1 or 2, the answer is, my dear friends, see, either 1 or 2 follows, either 1 or 2 and 3 follows. This is either 1 or 2 and only 3 follows. 3 is definitely correct, but among 1 and 2, my dear friends, among 1 and 2, either or we have to go. Yeah, first one is correct in few diagrams, at that time second one wrong. When second one is correct, first one wrong. A lot of people are saying like, say, first one conclusion wrong, second wrong, both. No, it's actually either 1 or 2. You draw other diagram also, I am sure. Okay, you just keep in mind this point, my dear friends. Either or means both not false at a time, both not true at a time. Let me know any diagram you draw with respect to these statements where both conclusions are false or where both conclusions are true. No such case. Definitely one among this is true, okay, other one false. That's why we have to go with answer either 1 or 2 and only 3 follows, my dear friends. As it is memory based question, we didn't get the options from the students, but guys, okay, you can go ahead with either 1 or 2 and only 3 follows. If suppose question is like, among these 3, which is correct, if they mention only, okay, these are the 3 options A, B, C, which among this A, B, C correct means C is correct. If they given options like either or means this is what? It depends on the options, dear. I given you the concept actually, but depends on the options you have to conclude the answer. What I mean to say, in options you don't have either or. If you have only 3 follows, yeah, go ahead with that only 3 follows. It purely depends on the options, dear, right? Now, see 2 more questions. One question is regarding perimeter they given. If area of equilateral triangle, square and circle is same, area of equilateral triangle, square and circle is same, then find the ratio of their perimeters. Find the ratio of their perimeters. This is the question they given, my dear friends. Find the ratio of their perimeters. Area is same, area of equilateral triangle, okay, square and circle. If you recall, in GATE 2018 there is a question, perimeters of these 3 are same. What is the discussion is regarding the area. Now they slightly changed the question. They given area is same. You can recall in GATE 2018, 2 marks question given. Perimeter same, area you have to find, but now areas of these three are same. What about the ratio of their perimeters? So guys, we know area of equilateral triangle is nothing but s square root 3 by 4, considering side is s. When side is a, okay, area of the square is nothing but a square, and yeah, area of circle where radius is r, we can write pi r square. All these are equal. They mention the question area of equilateral triangle, area of square and area of circle are equal. Let it be equal to k. Let us consider it is equal to k. Or some value also if you want, you can consider, no issue. From this, I can write, okay, S is nothing but equal to, yeah, what you got? 4k divided by root 3 s square. S means 2 root k divided by 3 power 1 by 4, my dear friends. Why 3 power 1 by 4? Already root 3 is there. S square, okay, again I have to do square root for that. It will become 1 by 4. Yes, I am mentioning, comparing first and last, I can write S is like this. And similarly, comparing first and last, A is nothing but equal to root k. And comparing this to radius is nothing but equal to root k by pi. Sir, why you are considering all this? You want to find ratio of their perimeters. Perimeters, you know, for equilateral triangle perimeter is nothing but 3s. For square perimeter is 4 sides, all are equal 4a. And for circle, my dear friends, perimeter or circumference, both are same. It's the length of the wire. You have a wire, you can form a equilateral triangle using that. You can form a circle, you can form a square as well. This ratio you have to find, my dear friends. Yes, already you know it is 2 root k divided by 3 power 1 by 4. So 3s means 3 into 2k, 6k divided by 3 power 1 by 4. Okay, as s is 2 root k divided by 3 power 1 by 4. Yeah, this is 6 root k. Fine, then let's see about a value is root k already you know, as you have 4a, 4 root k. R is nothing but root k by pi, it's 2 pi root k divided by root pi. Root k is common in all, you can get cancelled, and still 2 is also common, 2 1s, 2 2s, 2 3s. 3 divided by 3 power 1 by 4 can be written as 3 power 3 by 4, and here 2 pi divided by root pi can be taken as root pi. So guys, again options are not given from your friends, they just given the question. It depends on, again, options we can write in different format. It may be pi power 1 by 2 or pi can be considered as 22 by 7. It depends on what is the option they given. Accordingly we have to change, but this is the concept here. Very simple question. Area given, from that we have to go for perimeter. And last question, my dear friends, we have, this is 5th question. Let's see the 6th question. Related to clocks, they given one question, my dear friends. Basically this question, if people don't know the concept, they'll do the mistake. Very simple question. How many times hands of a clock, how many times hands of a clock coincides in 12 hours, coincides in 12 hours. They can ask 24 hours like that. Okay, this is also question given in forenoon session, my dear friends. How many times hands of a clock? Hands of a clock. In the sense minute hand and hour hand. Don't consider second hand. By default in clocks concept, hands means minute hand and hour hand we should consider. How many times hands of a clock coincides in 12 hours, my dear friends? So guys, see, for 1 hour, in 1 hour, one time it will coincide. In every 1 hour, hands of a clock coincides one time. Then many people have a thought that, sir, in 12 hours 12 times. No, in 12 hours 11 times only. 11 times only it will coincide. What is the problem? What's the best example for coincide is 12 o'clock. That itself will give the problem, my dear friends. Coincide means, yes, the gap between minute hand and hour hand is 0. Or angle between minute hand and hour hand is 0 degrees. Then we can call coincide. 12 o'clock is the best example. That is the trouble for us. Why 12 hours, not 12 times 11 only. And similar case for right angle, okay, or similar case for opposite also. What are the best example is there? That is the problem. Sir, how? Okay, why you are taking only 11 times? I'll just give you the practical values also, my dear friends. See, between 12 and 1 o'clock, when it will coincide is 12 o'clock. You can check. Between 1 and 2, you may assume 1, 5, but exact is 1, 5, 5 by 11. Between 2 o'clock and 3 o'clock you can observe it's 2, 10, 10 by 11. Between 3 and 4 you can observe it's 3, 16, 4 by 11 my dear friends. Between 4 and 5 if you just go ahead it's 4, 21, 9 by 11. This is the exact timings when you may assume 4:20 but exact is 4:21, 9 by 11. You can go through the clocks concept, you can see all these things, right. Whereas here 5, 27, 3 by 11. Between 6 and 7 it's 6:30 to 8 by 11. Between 7 and 8 when it will coincide exactly is 7:38, 2 by 11. Between 8 and 9 my dear friends it's 8:43, 7 by 11. Then 9:49, 1 by 11. Between 10 and 11 o'clock, between 10 and 11 it's 10:54, 6 by 11. Next, between 11 and 12, the problem is again 12 only. This is the issue. You can observe here clock's timings also exactly. The problem between 11 and 1 o'clock. 11 to 12 also 12 is the common point. For 12 and 1 also 12 is the common point. That is why -1 we did here. For 12 hours while 11 turns -1, that problem I already mentioned. The best example is 12 o'clock. That is the triggering point. For 11 and 12, 12 only. For 12 and 1 also 12 only the point. This is the common in both. So that's why we are doing -1 there. Why not 12 sir directly? We are doing -1. This is the reason my dear friends. Similarly you can take an example for right angle if they ask, for opposite also. This is what my dear friends from my side. Aptitude, okay, we collected around 6 questions. Okay, hope you understand this is all moderate to easy level questions. So next is mathematics subject my dear friends. BMK sir will continue that. So please. Thank you guys.
Good evening everybody. Today we have collected from the memory of our students 5 to 6 questions in mathematics right now. If I get one more question or some other questions before closing my session, that also I'll deal with you. So let me take first question first. This is a very simple question. You observe this matrix 10, 2k plus 5, 3k minus 3, k plus 5 is symmetric. So I have some derangement, no problem. So I'll go with this. See, this is a wonderful problem. P equal to this limit extends to pi x square plus alpha x plus 2 pi square by x minus pi plus 2 sin x. Then alpha value what? P value what? The options are also very clearly given. Let us work out. See, P for some finite value, right? If you substitute directly x value pi, then this is limit extends to pi x square plus alpha x plus 2 pi square by x minus pi plus 2 sin x. If you put directly x value pi, what is the situation? Pi square plus pi x plus 2 pi square divided by pi minus pi plus 2 sin pi. We know sin pi is 0. So, this value 0. Right. Now, 3 pi square plus pi x, here pi minus pi is 0. So, we have here 3 pi square plus pi x by pi minus pi 0 plus 0. Something by 0, indeterminate, infinity, but it is given p. That means if it is 0 by 0 form, that means L'Hospital rule is applicable. Then we can continue to find that p value. So, if it is 0, 3 pi square plus, it is alpha x, this is alpha x, 3 pi square plus alpha x is 0 means alpha x, alpha value must be 3 pi square minus 3 pi square, alpha must be minus 3 pi. Is it available? Yes. So, it is there. So, you can discard option A and option C. Okay. Next, I want to continue. So, here alpha is minus 3 pi, I am replacing p equal to limit extends to pi x square minus 3 pi alpha plus 2 pi square divided by x minus pi plus 2 sin x. This is the situation. Now, if you continue this procedure, you get 0 by 0 form. So, next step, to decide the value of p, L'Hospital rule we can apply. So, I continue in the top. So, our p is now limit extends to pi. So, numerator, denominator separately differentiate. X square gives 2x minus 3 pi x, x gives 1 by, in the denominator 1, 2 sin x gives 2 cos x, right. Now, put x is pi, 2 pi minus 3 pi by 1 plus 2 cos pi is minus 1. Then the value is here minus pi by minus 1, simply pi. So, where it is available? Minus 3 pi and pi. Minus 3 pi minus pi is wrong. So, moderately it is a good question, 2 marks worthy question. Now, next problem. Yeah, this is looking big. Del square t means dou square t by dou x square dou square t by dou x square plus dou square t by dou y square equal to 0. Here several conditions are there. T of x comma 0 is x, T of 0 comma y is y, T of x comma 1 is x plus 1, T of 1 comma y, y plus 1. Then what is T of x comma y? So, intelligently in examination time, better our function should satisfy all these conditions. If you substitute T of x comma 0 where it is x, so put y is 0. So, here x, so this is correct. here x correct, here correct, but here minus x comes. So you can neglect this. One option discarded. T of 0 comma y is y. Put x is 0. You should get y. This is y. This is y. This is also y. Correct? Then go to the next condition. X comma 1, x plus 1. You write here y value 1. So here x minus x 0, 1. It is x plus 1. This is not satisfied. So T of x comma 1, x plus 1. So this is satisfied. Next, T of x comma 1. So if you put y value 1, here x plus 2y. So this is not correct. Like that, within a minute, you can solve this. Correct? Next. This is a wonderful question. See, the system of linear equations, first xy given, this is the matrix A given, this is 0, 0. It has infinite number of solutions. Infinite number of non-trivial solutions means non-zero solutions. For some value of A, then what are the values of x and y means what is the solution? And let us see like this. If we multiply directly, so xy into this column, 2x plus ay. Next, this row, that column, 5x minus 5 minus 2a into x. So here 5 minus 2a into x plus y should be 0, should be 0. So this is the system of equations given. So you can present them like this: 2a, 5 minus 2a and 1 into xy equal to 0, 0. So they have confused us by giving like this. We know this type of notation. So this is in the form now Ax equal to O form. This is familiar to you. So to get infinite number of non-zero solutions, this matrix A must be singular. That means det A should be 0. So here itself det A means 2A, 5 minus 2a, 1 should be 0. Then only we get infinite number of non-zero solutions. Then simplify 2 minus a into 5, 5a minus minus plus 2a square equal to 0. Right? Now factorization and roots finding. So better 2a square 5a split into minus 4a minus a, that is more easy. Finding roots is simple. 2a common, a minus 2. Here minus 1 common, a minus 2. So a minus 2 into 2a minus 1. Then the values of a, 2 and 1 by 2. So a equal to 2 and a equal to 1 by 2. Right? If I put here a value 2, simply I am replacing here only. If a value 2, here 2a 4, then 2 2 5 minus 4 1, 1 1. Then the equation is at a equal to 2. We have the relationship 2 2 xy 1 1 xy. That means x plus y is 0. We have the relation x plus y equal to 0. So in the given options, where x plus y equal to 0, check. So it is not giving x plus y 0. It is not giving, but this is giving. In that way you can solve. But We have verified this only for a value 2. Similarly, for other value of a is 1 by 2 is there. You can verify that. So, a equal to 1 by 2. So, better directly if you replace here. So, 2 1 by 2. So, at a equal to 1 by 2, the relation don't take complexity 5 minus 2a like that. So, here 2, here a. So, 2 plus 2x plus so here 2x plus 1 by 2 into y should be 0. So, this is another important relation. So, where it is satisfying? You observe y by 2. So, here you observe y by 2 is there, na? So, here you observe 4, 1, minus 2. Better such values if you substitute 4 by 2, 2. Correspondingly, x value is what? Minus 1. So, minus 2 plus 4 by 2 will give 0. So, this is also true. Then other values 1 comma 1 if you substitute it will not satisfy. 4 comma minus 2 right here? No. So, this is a wonderful question because generally we are habituated Ax equal to O form. First x given, next a given. Then if you do like this and going with options like this, you will be successful. In my view, among the questions related to mathematics, first time I have seen like this. It is MSQ question, multiple select question. Okay. Next question. This is one standard problem. Nothing big at all. 2 marks also easy to score. Here you observe a random variable x follows Poisson distribution where p of x equal to 1, p of x equal to 2. Then what is p of x is 3. You know p of x equal to r e power minus lambda into lambda power r by r factorial. Standard formula everybody can remember. So, p of x equal to 1 means put r value 1 e power minus lambda power 1 by 1 factorial 1 should be p of x equal to 2 e power minus lambda square by 2 factorial 2. Then simply you can e power minus lambda can be cancelled. So, 1 lambda can be cancelled. Simply lambda value 2. That means mean is 2. If you know lambda value is given, then whatever it is p of x is 3, put r is 3. So, p of x equal to 3 based on that lambda value e power minus lambda 2 lambda power r 2 power 3 by 3 factorial. Simplification, it is 6 here 2 cube na 4 by 3 is square. So, virtual calculator you can apply and you can simplify this as 0.18. 2 marks worthy question. So, it is numerical answer type question, no choices, confidently we can solve. 2 marks easy to score. So, one more problem, this is the simplest problem. In my view, what we have gathered today among the 5-6 questions, which is very easy. This is very easy. Symmetric matrix, definition you know. Any matrix is symmetric means, forget about the diagonal elements, right? These two must be same. Aij equal to Aj. That means 2k plus 5. Must be 3k minus 3. So, better this 2k other side, that minus 3 this side, 5 plus 3, 3k minus 2k. Therefore, k value 8. That is why 1 mark only. So, any person even without coaching also it can be solved. Now, one more question. if it is available, okay. I have with me one more question just I have received. So that data also I write. Thanks, man. Just my friend has given this question now. I want to explain that. It is also wonderful. If phi equal to 1 by 2 into x square plus y square plus z square, then double integral over s del phi dot n bar ds equal to what? Where S is a unit sphere. This is the last problem I have with me now. Options also given 4 pi, 3 pi, 0, 4 pi by 3. See, it is also very simple and very standard question. This type of problems already you know in the coaching or in your past career. Let me see. I want to find del phi dot n bar. Our S is what? Unit sphere means closed surface, right? First, what is this del phi? We should know that. So calculate. Del phi equal to half is common, dou phi by dou x, 2x by 2, xi bar. Dou phi by dou y, 2y by 2, so yj bar. Dou phi by dou z, 2z by 2, zk bar. This is del phi. That is nothing but r bar. Okay. Since our S is a closed surface and this is what some f bar I am calling. F bar dot n bar ds. S is a closed surface. Then we can apply Gauss divergence theorem. So this value is now triple integral over V divergence f bar dv. Correct? So what is that divergence here? This is what f1 I bar, f2 j bar, f3 k bar. Dou f1 by dou x is 1. Dou f2 by dou y 1. Dou f3 by dou z 1 dv. So this is simply 3 dv or by integration 3v. What is that v? Volume of that unit sphere. So 3 into 4 third pi r cube. Here unit sphere given r is 1. Simply you can cancel that 3. Answer 4 pi. Is it there? So this is the confidence we can get at the time of examination, no confusion. So more or less 5-6 questions, whatever I have collected, that I have presented. Now I am going to hand it over this session to my colleague, FM subject I think, engineering mechanics, by my colleague Bari sir. Thanks.
Good evening. I will be taking the question of subject engineering mechanics. As of now, I'm only having two questions. One question happens to be from the concept of friction. The other is from the basics of general plane motion. Let us look at this question. This question has come for 2 marks. I do not know exactly what was the statement given, but roughly the statement goes like this. You have to find out the ratio of coefficient of friction at point Q and point P. I do not know which point is Q and which point is P. I'm assuming this is Q and this is P. Accordingly, we'll find out the solution. Let us see now. If you look over here, the given diagram is a very simple structure which is having 2 roller supports over here. Okay? It is given to us that this distance is 5 units, this is 12 units, and this angle over here is 90 degrees. So by basic triplet you can say 5, 12, this has to be 13 units. This has to be 13 units. Now, how do we find out the coefficient of friction? To find out the coefficient of friction, I have to maintain this particular structure at equilibrium. For me to maintain the structure at equilibrium, I can straight away say summation of force vector has to be 0. Likewise, summation of moment vector about any point has to be 0. I'll concentrate purely on summation of force vector. If I look at summation of force vector, since it's a planar case, I will say summation of force in x-axis has to be 0. Likewise, summation of force in y-axis has to be 0. Look at this equation of summation of force in x-axis equal to 0. By summation of force in x-axis equal to 0, I'll be getting only 2 forces. Which 2 forces? I'll be having the friction force present at point Q and friction force present at point P. If you look at the free body diagram should look something like this. Let us say you're having 2 reactions over here. Let me call this as NQ and this as NP, and the friction forces over here. Now by the virtue of the force W acting over here, this tends to move on the left hand side, therefore the friction force is this way. Let us say this is FQ, friction force FQ, and this way is friction force FP. Summation of Fx equal to 0 would imply that the value of friction force at point P and point Q, both of them have to be same. So I can say the friction force at point P has to be friction force at point Q. Now what is friction force at point P? It has to be equal to mu at point P multiplied to normal at point P. Likewise, this has to be equal to mu at point Q multiplied to normal at point Q. Normal at point Q. One moment please. Mu Q upon mu P would then be equal to NP upon NQ. Mu Q upon mu P is equal to NP upon NQ. Now how do I get the value of this thing? Now this is something like a simply support beam on which you are having a point load acting. You must be knowing for a simply support beam, let us say if you have a point load acting over here, then if this distance happens to be some distance A, the reaction over here would be equal to W into A upon L. Likewise, the reaction over here would be equal to W into L minus A upon L. By that I can get the value of normal over here and normal over here. How do I get this thing? You see 5 and 12, if I find out this angle, let us say this angle is theta, how much would this angle be equal to? It would be equal to tan inverse of 12 by 5. Tan inverse of 12 by 5. So as to save time, I have identified the angles previously itself. The value of this angle theta is equal to 67.38 degrees. Once you get the value of this theta, you can identify the distances from here to here and likewise the distance from here to here. The value of NP is coming out to be equal to, one moment please. NP is coming out to be equal to 25 by 169Q, and the value of NQ is coming out to be equal to 144 upon 169Q. If you, one moment please. W rather. If you put in these two numbers over here, 25 upon 144, the value of mu q upon mu p would come out to be equal to 0.1736. The ratio of mu q upon mu p will be equal to 0.1736. Now, if any one of you has taken this as P and this as Q, exactly inverse of that would appear, and that value would be equal to 5.76. So depending on which point is which one, I am going to get two answers, 0.1736 for this configuration. If P goes over there, Q comes over here, the answer would be 5.76. I hope this is quite simple. It was based on equilibrium along with the concept of friction. Moving further to the next question. This question happens to be the simplest of all questions you would find in the paper probably, because it's coming from rolling without slipping, and that too on a stationary surface, horizontal stationary surface. Let us say there is some circular body, a disc or a cylinder, whatever it may be. If it is rolling without slipping, the omega value is given as 5 radian per second. The radius is given by as 0.15 meter. You are supposed to find out the velocity at the center. We know that rolling without slipping of a circular body on a stationary surface, it would give me the velocity at the center as r into omega itself. Okay, there are many ways of approaching this thing. You can also think of this as I center, this as your radius, and this as your velocity v. And that would be equal to how much? There is no need of calculator also. R is equal to 0.15 meter. Omega happens to be 5. 5 times 0.15 is equal to 0.75 meter per second. This is the velocity. This would hardly take 1 minute, I believe. Right? These two questions are what I have got. I'll hand over to my colleague, Mr. Umar sir. Please come in. Thank you.
Yes. Good evening, friends. Hope you did very well based on our preparation. So far, we are receiving the two questions from the strength of material, one from the deflections topic, second one the pressure vessels, but both are simple and simple questions. So first I am taking the problem from the deflection topic. Read the question. An L-shaped elastic member ABC with a slender of AB and BC of uniform cross section is clamped at end A and connected to a pin at end C. So we are fixing at end A and one pin we are providing at end C. This is a L-shaped elastic member. The pin remains in continuous contact with and is constrained to move a smooth horizontal slot. That means because of the pin, we are having the displacement. We can permit the displacement only in horizontal direction, but we are restricting the displacement in a vertical direction. Another information we are having, the section modulus of the member is the same in both the arms. So section modulus, it is related to the bending action, as we know. The end C is subjected to a horizontal force P, and all the deformations are in the plane of the figure. That means entire frame we are placing on a single plane. Given the length of AB is 4A units and the length of BC is A units. What we required? The magnitude as well as the direction of the normal force on the pin from the slat. If you take the figure for this one, this is a L-shaped frame. At this end, we are having the pin. Here we are observing the horizontal force, my dear friends. This type of problems generally we can solve by using the Castigliano's approach, but here we are using a short trick. Now what is the short trick? Simply I can shift this force to the point B. This force, horizontal force. Because of the horizontal force, yes, we are permitting only horizontal motion. We can completely restrict the vertical displacement. Now, whenever we are shifting the force, yes, that shifting force, it is causing a additional moment. How? The additional moment, it is acting anti-clockwise direction. Look at here, this one. What is its magnitude? P and this distance we are having, PA. Now see this, at the B, this moment, it will try to give the deflection in upward direction. But completely here, the pin, it is permitting only horizontal motion. There is no vertical displacement. Immediately, yes, reaction will be generated at the pin in downward direction. When this movement, it will try to give the upward deflection. Yes, this reaction, it will try to give the downward deflection. So ultimately, when you take the net deflection at a B in vertical direction, that should be 0. I am using this condition. Now first, you can take the effect of this concentrated movement at point B. Yes, it is giving the upward deflection. As it is giving the upward deflection, I am taking it is positive. What is the upward deflection given by moment M at point B? And this R, it will try to give the downward deflection. Downward deflection, I am taking it is a negative sign. Deflection at B due to the reaction R should be, it is 0. This is nothing but a compatibility condition. So then the problem is very simple. It's a treat this as a cantilever beam. You know, because of a point load at the end of the cantilever, what is the deflection we are having? Similarly, because of concentrated movement at the end of the cantilever beam, you know what is the deflection. Simply I can substitute that. Now let me take this one. Del B in vertical direction due to the M equal to del B due to the reaction or in vertical direction. Say this is a standard formula, ml square over 2EI, that should be equal to, this is a RL cube divided by 3I. Simply you can substitute the values, every value we know, simply we can substitute that values. Here M, it is a PA, and L, if I take the L, here clearly mentioned, the length of the AB arm, it is 4A units. And just you simplify, then you are getting reaction R equal to 3P over 8, my dear friends. But in addition to the magnitude, they are asking the direction also. Or it is, we are observing in downward direction. As per the given options, option D is correct in this case. This is the first question what we received from students database, that is from topic deflections. It's a very simple thing. We can solve this by using a Castiglione's approach also. The next one what we are received is from pressure vessel. It is also one of the interesting and simple question. Yes, go through this question. A thin-walled cylindrical pressure vessel had the mean wall thickness of T units. Yes, as we know, thin pressure vessels are considered as a biaxial stress problems. What is the thickness it is given? In radial direction, that is a T. And the nominal radius is given as R. Nominal radius of the pressure vessel, it is given as R. And in addition to that, here the material property of the vessel in the form of a Poisson's ratio is given. What is its Poisson's ratio? Poisson's ratio is 1/3, it is given. When it is subjected to some internal pressure, its nominal perimeter, that is nothing but a circumference in the cylindrical portion, increases by, it is 0.1%. 0.1% we are observing, that is nothing but epsilon hoop strain, epsilon h, that is given as a 0.1 divided by increase in this one
100. And the corresponding wall thickness becomes some change. Definitely we are observing in the thickness. The thickness it is given as a T bar. The corresponding change in the wall thickness of the cylindrical portion, we need to find out this one. See, what is the data we are having? We need to find out the strain in radial direction. That is nothing but del T, I can write this as divided by T. Final minus initial divided by initial into 100. This we require. This is related to the dimensional changes problem. Simply we know what is the hoop strain we are observing. Yes, as we consider this is a thin pressure vessel problem is a biaxial state of stress. As we know, when you select the element, just I am representing the state of stress on this element. When I am representing the state of stress, yes, here we are having sigma L, as we know, with a magnitude of PD over 40, and here we are having a sigma H, that is hoop stress PD over 2T. So what is our observation from this one? Sigma H, it is 2 times sigma L, my dear friends. Now what we required? Epsilon T. Basically it is a radial strain. Radial strain we are observing because of Poisson's effect, we are observing the radial strain in the vessel. That radial strain we can find out by using this relation, minus mu times sigma H divided by E minus mu times sigma L divided by E. I can substitute this condition in sigma H, that is 2 sigma L. It should be how much it is given as 0.1%, my dear friends. Now if I simplify this one, I am getting this is a minus mu, if you take it as common, then 2 plus 1, it is a 3 sigma L divided by E. This is the term we are having. But how to find out this term? We are not having any information about this one. Yes, as we know, hoop strain, sorry, this is not given. This is a hoop strain value clearly mentioned. This is hoop strain value, change in hoop strain that is given. Now, we required sigma L upon E, that I am getting from the hoop strain. Hoop strain that should be equal to sigma H divided by E minus mu times sigma L divided by E. When you take this one, clearly 2 sigma L, I can take this one, 2 sigma L divided by E minus mu times sigma L divided by E equal to, now you can take this value, 1%. Is it right or not? Now from this one, if you take this, already mu value is given, na? Exactly, mu value is given. Then you can substitute this value. If you substitute, you are getting a 2 sigma L divided by E minus 1 upon 3 sigma L divided by E equal to 0.1 divided by 100. Here only unknown term, if you take from this relation, we are getting a sigma L divided by E. What is sigma L divided by E? If you simplify, approximately you are getting a 0.0006. This 0.0006 you can use. You can use it here. Here you can use this one, that one. If I take this one, now look at here, minus mu value it is given as 1 divided by 3. 3 into sigma L divided by E, we are having 0.0006. So 3 is getting cancelled. Then what is epsilon T? That is T bar minus T divided by T into 100. Approximately it is 0.0006, my dear friends. This question we are having from the thin pressure vessel. So far we are getting these 2 questions only. Now my friend will take the charge for him from thin theory of missions. All the best.
Hello everyone, I'll be discussing the topic theory of machines. So total we have 3 questions from this topic, and the first question is from the topic of vibrations. So here the simple arrangement is given. A mass is connected with the spring to the fixed end, and there is another mass connected with the help of rope and pulley arrangement. Okay. So this rope we will be assuming that as inextensible rope or rigid. Okay, and we need to relate the displacements of the mass capital M and the mass small m. Okay, so what I can do is, this will be the distance, let us say length of the rope x in the horizontal direction. Okay, and this will be the length of the rope. So it is being tied up till here. From this point if I measure, from this point if I measure, it will be 2 times of y. 2 times of y it would be. Okay, so I can write here x plus 2y is equal to constant. X plus 2y is equal to constant. Now if I differentiate this, so capital X, X is the displacement of capital mass, the X is the displacement of mass capital M, and Y is the displacement of mass small m. Okay, so here if I differentiate this, that is x dot is equal to minus 2 times of y dot. X dot is equal to minus 2 times of y dot. So I have related the coordinates of these two masses with the help of the equation. Okay. Now here we can apply the energy approach. So here first it will be spring energy, and the spring will be getting displaced with the spring will be having the displacement of x. So this will be half kx square, half kx square will be the spring energy. Similarly, the kinetic energy will be possessed by the mass capital M. So half m x dot square. Okay. Similarly, the energy possessed by the mass small m will be half into m times of y dot square. So this will be equal to constant. This will be equal to constant. All I need to do is differentiate this equation. So this will be dE by dt is equal to 0. This implies it would be half into k into x, or it would be 2x, it would be 2x into x dot plus, next would be half into m, this is x dot, so this will be 2x dot into x double dot, Next the third term would be half into m. Now here I need to express this differential equation or the energy equation in terms of a single coordinate, that is x dot. Okay, I need to express that in terms of a single coordinate. So what will be y? Y here I am supposed to write it as, or y dot basically it becomes as x dot by 2. It becomes x dot by 2. So here if I differentiate this, it will be 2y dot into y double dot is equal to 0, So half will be cancelled and x dot will be cancelled, half will be cancelled and x dot, half and yes. Here I need to replace this y dot and y double dot, okay. So here the equation becomes mx double dot, sorry, it is capital M, it is capital M x double dot plus small m y dot y double dot, just a minute, I forgot one term, capital M x dot x double dot, and the next term would be kx dot x is equal to 0. 2 and half will be cancelled here. So here what I can do is mx dot mx double dot is plus m into y dot is x dot by 2. Y dot is x dot by 2. Y double dot is also x double dot by 2. Okay, and the spring force or the spring energy, it would be kx dot x is equal to 0. Now you have expressed the differential equation in terms of a single variable. Okay, so x dot and x dot will be cancelled. Right, so this will be x double dot capital M plus small m by 4 plus k times of x is equal to 0. This is the standard differential equation for undamped vibration. So here I can write that as x double dot plus k by capital M plus small m by 4 times of x is equal to 0. So this term will be omega n square. This will be omega n square. So omega n will be root over capital M plus small m by 4. So this is the question what we have received from the student database, and let us proceed to question number 2. Yes, here there is a planetary gear train is being given to you. Okay, so let us read the question. The arrangement consists of sun, planet and ring gear. The number of teeth on planet and ring is, the number of teeth on planet, actually the number of teeth on planet is 20. Okay, so I will write it as ZP. Z represents the number of teeth on planet is 20, and the number of teeth on ring gear is 80. Okay, if the speed of ring gear is 900 rpm, so NR is equal to 900 rpm, and the sense of rotation is counterclockwise. Okay, and the sun gear is fixed, so NS or N sun is equal to 0. Then the speed of arm is equal to dash. What is the speed of arm? That is what you are required to determine. This is a standard question. We have been seeing this question repeated almost more than 5 to 6 times over last 15 years, I would guess. Okay, so a simple question it is. So first is that we are required to determine the number of teeth on the sun gear. ZS is missing, so that can be done very easily. Okay, so radius of one or radius of sun, this will be sun gear, this will be planet and this will be ring. So I can write an equation for that, that is radius of ring gear is equal to radius of sun plus diameter of planet. Okay, next is this radius can be simply, yes, first I need to express this in terms of radius. So radius of ring is equal to radius of sun plus 2 times the radius of planet. Okay, and these can be replaced by teeth also, because the module, all the gears are in mesh, so they are supposed to have the same module. So I can simply replace this radius with the teeth. So TR is equal to TS plus 2 times of TP. Okay, TR is given to us as 80, I guess it is 80. okay, it is 80, and Ts we need to find. Sorry, here I am supposed to use Z actually. The subscript should be Z actually. We are using Z to represent the teeth, ZR, ZS and ZP. Okay. Plus 2 times of 20 it is, 2 times of 20. So the number of teeth on sun gear will be equal to 40. The number of teeth on the sun gear will be equal to 40. Now, gear 1 and gear 2, that is sun and planet, are in mesh. So we can write an velocity equation for these two. That is ns minus an arm. There is an arm also connected. Okay, for this arrangement there is an arm also connected. So ns minus n arm divided by n planet minus n arm, this is equal to minus Zp by Zs. The gear 1 and gear 2, that is sun and planet, are in external gearing. So that external gearing has to be reflected by the negative sign. Okay. So the second equation what I can write is, that is planet is in mesh with the ring gear. Planet is in mesh with the ring gear. So I can write this as Np minus n arm divided by n ring minus n arm is equal to, the teeth of ring should come on the top and the teeth of planet should come in the bottom. This will be the two equations, guys. Equation A and equation B. Now if I multiply these two, then it would be n sun minus n arm. Okay, planet and planet will be cancelled, that is Np minus n arm and Np minus n arm will be cancelled, and similarly that is you will be left out with that is speed of sun minus arm by speed of ring minus arm. This is equal to that is ring gear, that is ZR, so is supposed to be on the top, that is numerator, and yes, ZR is supposed to be in the numerator. If I multiply A with B, okay, and ZS will be in the denominator. Okay. So next what I need to do is, I need to substitute the value. Only 900 RPM is given to us, and the sun gear, the velocity of sun gear is 0. Okay. So ns. Okay, let me just do it here only. So ns is 0 minus nr divided by nr, that is 900 RPM. I am assuming 900 to be that is counterclockwise to be positive. 900 minus nr is equal to ZR by ZS. Okay, that is ZR is minus R is 80 divided by ZS is 40. Okay, so this will be minus 2, and then upon solving this, I will be getting n arm is equal to 600 RPM, and this will be a positive value, which means that the arm will be rotating in counterclockwise sense. Okay. So this was another simple question, a standard one. Moving to next question. Yes. A system is described by the equation. Yeah, this question is actually from the vibrations. Okay, and it is a 2-mark question actually. So what is the data what we have received from the student, with reference to that I am mentioning. So here the system is described by the equation, that is x double dot plus 2 times of zeta omega n x dot plus omega n square x. Okay, that is a second order damped system. Okay, omega n represents the natural frequency, that is very well known to us. Omega d represents the damped frequency. Okay, and omega p, that is a new term. Basically this omega p represents the frequency where the peak
of I would say dynamic magnification factor occurs. Okay, we'll see. I'll try to explain you omega p with the help of the plot. Okay, so these are the conditions given, guys. Omega d is equal to omega n greater than omega p. Okay, similarly for option B and D. So let us just first understand the omega p and then I'll come to the options. Okay, so here this will be R, this will be R. R basically represents the ratio of frequencies, that is omega by omega n. Okay, and this will be x max by x naught, which we call it as dynamic magnification factor, DMF. Okay, dynamic magnification factor, what we call it as DMF. Okay, so if we plot for different values of R and different values of zeta, you will find here this will be R is equal to 1. This is R is equal to 1. Okay, so in the dynamic magnification factor will be equal to infinite at R is equal to 1 and zeta equal to 0. Okay, this will be infinite at zeta is equal to 0 and R is equal to 1. So as we keep increasing the zeta value, that is the damping factor. As we keep increasing the zeta value, the damping factor, we will find the peak of this dynamic magnification factor. The peak of this curve will tend to shift towards the left hand side. The peak will be tending to shift towards left hand side, which means that R is, that is omega n will be greater than omega p. Omega n will be greater than omega p. The peak is going to shift towards left hand side, right? So this is one observation, guys. This is one observation, right? The next observation, we know the mathematical relationship between the damped frequency and the natural frequency. That is omega d is equal to omega n times of 1 minus zeta square. 1 minus zeta square. So from this expression we can conclude that omega d is less than omega n, right? Omega d is less than omega n. Okay. Now checking the options. Omega d is equal to omega n. This is wrong. This is wrong. Okay. Next option is that omega d is equal to omega p, but both are less than omega n. This is a possible option. This is a possible option. Okay. The option C says that is omega d is equal to omega n. This is also once again wrong. Okay. And the option D says omega p is equal to omega n. Even this is wrong. So if you observe this graph carefully, and you understand that is with the increase in zeta values, zeta as it increases, okay, the peak of this dynamic magnification factor curve will be shifting towards left hand side, that is omega p will be less than omega n. Okay. So these were 3 questions from theory of machines topic, and I would like to invite my colleague Dharan sir to take forward this discussion. Thank you.
Good evening, everyone. I hope you people are doing good. I hope you people have written the exam well. So let me go with the questions which were asked from machine design. So from machine design, we have got a question from joints. Yes, this question speaks something like this. There were 2 plates which are held together with the help of rivets, and here the arrangement is as shown in the figure. Here if you observe carefully, see, whenever we get such kind of loading conditions, first we need to observe load, the load whatever is given. Here if you observe this load is parallel to this cross section of elements that we have. As the load is parallel to the cross section, and if I find the CG of these 2 elements, see, where do we have CG? Generally about the axis. Here, this is the axis of the first element, this is the axis of first element, and this is the axis of second element. But here if you observe carefully, as this is a system, for this system, I can say that the CG will be somewhere along the line joining these 2 centers. So that is about this simple point. Let me consider that this is the point where the CG is located. If you observe carefully, the load is not passing through the CG of this riveting system, and this is parallel to the rivets, the rivet cross section. So can we call this load as lateral load? Whenever the load is parallel to the cross section, we call this as lateral load, and this lateral load is not passing through the CG of the system, so we are calling it as eccentric lateral load. See, we know that whenever the load is eccentric in nature and that is a lateral load, here we'll be having two effects. Primary effect, let me write here. So eccentric lateral load will be having generally two effects. One is primary effect due to direct load. This is primary. And the other one is secondary. See, secondary is due to moment and primary is due to direct load. As we can see that this direct load is parallel to the cross section, this primary load is a shear load. This is a shear load. And here, as this is eccentric lateral load, whatever the moment that we are getting, this moment will be shearing the elements, which means even the secondary load is a shear load. And we know how to find primary and secondary loads. How to identify primary? We know that primary FP is nothing but equal to number of elements, the total load divided by number of elements. What is the total load that we have? Which is 10 kilonewtons divided by number of elements that we have, what? 2, just 2. Okay, which means we are getting this as 5 kilonewtons. That's well and good. Now let me identify what is secondary load. We know the equation for secondary load. So what is the equation? So secondary load equation is nothing but moment divided by distances square. Here you can see the distances. Here it is from CG of the system to the center of the elements. I am going to consider the distances here, R1 square plus R2 square into R. Here we are not interested in any intermediate value of secondary load. Generally we are interested in finding the maximum value of secondary load. See, primary load is same on all the elements, but secondary load decides the critical element here. Here to find out the critical element, I need to find the maximum secondary load. So for this secondary load to be maximum, R value to be maximum, we have got only 2 elements. Here for these 2 elements, the R value is same, which means here we can say that both the elements are critical. Okay, let me identify what is secondary load. Secondary load is nothing but equal to what is the moment that we have? Moment is nothing but the load into eccentricity. What is the eccentricity that is given here? 3 root 7a. Okay, so that is load is 10 kilonewtons into eccentricity that we have is 3 times root 7 into a divided by what is R1 here? It is the distance from CG to the center of element, which is nothing but a. So this is a square plus a square. And into what is R maximum? Here I am going to find out maximum secondary load. This is maximum secondary load. So this is coming out to be, observe here, this is a simple calculation. This is a simple calculation. Here a square gets cancelled out, and denominator we have 2. So 2 into, sorry, here this is 5 into 3, 15. This is 15 root 7. Now we have primary load and secondary load, and here we know that primary load will be in the direction of loading and secondary load is in the direction of moment. See here, this is the primary load, and if I consider moment, this to be the direction of moment, secondary load on both the elements will be in this manner. So this is secondary load on top element and secondary load on bottom element. See here, I need to identify the resultant here. Let me identify the resultant. So what is resultant here? I am going to find out maximum resultant. So which is nothing but square root of Fp square plus Fs square. Here if you observe carefully, the value of theta between these two is 90 degrees. Okay, so that's the reason why we are eliminating the cos term here. So this is 5 square plus 15 root 7 whole square under root. So if I calculate this, I'll be getting this value as R maximum as 40 kilonewtons. So we have identified the critical element as well as we have identified the maximum load which is acting on the critical element. Now let's design this member. See here, what is he asking us to find? Here he's asking us to find the area of the rivet. Let's identify this. So how can we identify this? Let me consider the design condition. design condition. So we know that when maximum stress due to loading exceeds the failure stress, yes, the element is going to fail. Here, if I consider factor of safety, here as factor of safety is not given, let me consider this to be equal to 1. Okay, which means from this, when we consider factor of safety to be equal to 1, we will be getting the least possible dimension that we need to give to the element. Okay, so here what is tau maximum, which is nothing but R maximum divided by area. R maximum is nothing but 40 kilonewtons, 40 into 10 cube divided by area of rivet is equal to, what is the value of tau failure that is given? See, in examination it is given like permissible shear stress whose value is 50 megapascal. If I substitute the same thing here, this is 50. So if I proceed further with the calculation, I'll be getting area as 800 mm square. So this is the answer for this simple question. And there was one more question which was asked from fatigue loading. What was that question? Let's see. So the question was something like this. So this was based on the memory of my student. No, as he said, as he replicated the same thing, I'm going to replicate the same thing to you. So it was given like, he is asking us to find what happens, how can we increase the fatigue strength of the component? See, how can we increase the fatigue strength? Fatigue strength can be increased by, so what are the various ways? Yes, we know that there are various factors that we are inducing while finding the correct endurance strength of the component. So here in options, see, based on the options, this was given in multi-select question. Okay, so based on the options, we need to choose the right answer. See, there are various ways of increasing fatigue strength. Okay, that can be by increasing the surface smoothness or decreasing the surface roughness. Okay, or by going with induced compressive stresses. If we increase the induced compressive stresses, what will happen? Obviously, the life of component is going to increase in the options. So these two are given. It is given as short peening. See, we know that short peening is a procedure by which we'll be inducing compressive stresses into the component. So this is one option. And the other was given like increasing the surface smoothness or decreasing the surface roughness. See, decreasing the surface roughness, or increasing the smoothness of the surface, or going with super finishing of surface. Okay, we'll be getting we'll be having more fatigue strength. Okay, these are the two questions that came from machine design. So I hope so you perform well from these two questions. Now I would like to hand over the session to my fluid mechanics faculty, Abdul Bari sir. Pass.
Let us start fluid mechanics questions. As of now, I'm having 3 questions from fluid mechanics which have appeared in morning session. 2 of these questions have come from kinematics, one has come from drag and lift forces. This question happens to be a very simple question which says that the stream function is given by psi is equal to kx cube y, where k is equal to 1. The total acceleration at the point 1, 1 is how much? This probably was a numerical answer type question, probably was a 2-mark question. I'm assuming it was a 2-mark question because it is having 2 concepts. One is a concept of stream function, other is a concept of acceleration. So I'm assuming it was a 2-mark question. Let us see. First thing I have to do over here is identify the velocity vector. Since psi is given to me, let me write over here, psi is equal to kx cube y, k is equal to 1, so I'll write x cube y, x cube y. I have to get the 2 components of velocity u and v. I'm using the formula u is equal to minus of dou psi by dou y, which would imply the value of u is equal to dou psi by dou y is equal to x cube, minus of it is minus x cube. So this is the value of u I'm having. V over here would be equal to dou psi upon dou x. Now I hope you remember, if you take minus for u, you're not supposed to take minus for v. Or you can take a plus over here and a minus over here. So only one of them would get a negative. If you look at this value would say small v, that is y component of velocity, is equal to 3x square y. It is equal to 3x square y. That means my velocity vector over here is equal to minus x cube I cap plus 3x square y j cap. This happens to be a 2D steady flow. Of course, it is having x and y components over here. It is non-uniform flow. Now I have to get the value of acceleration. Okay, how do I get the value of acceleration? Let us start first of all with the component ax. The value ax is supposed to be equal to, I'll have 4 terms over here, but of which 2 terms are already 0. The temporal quantity which deals with time is equal to 0. Let me write the entire thing otherwise. I'll write dou u by dou t plus u into dou u upon dou x plus v into dou u upon dou y plus w into dou u by dou z. This would be the equation. I can straight away say these 2 values don't exist over here. Now the value of ax would be equal to, since u is a function only of x, even this value would not exist. Since u is a function only of x, even this value would not exist. The value of ax would be equal to how much? U is equal to minus x cube. Differential of this with respect to x would give me minus 3x square, which implies the value of ax is equal to, it is equal to 3x power 5. 3x power 5. He has mentioned at the point 1, 1, I can say at 1, 1, the value of ax has to be equal to 3 units. Ax has to be 3 units. Likewise, let us look for the value of ay. The value of ay would be equal to, again I'll write all these terms, dou v by dou t plus u into dou u by, dou v by dou x. I'm sorry, this is supposed to be u into dou v by dou x plus v into dou v by dou y plus w times dou v by dou z. Over here, this term and this term is not existing. If you look at the value of v, it was 3x square y. V was 3x square y. So I can write over here ay is equal to u is equal to minus x cube. 3x square y, if you differentiate with respect to x, partially differentiate with respect to x, you are going to get 6xy. So you are going to get over here 6xy plus v is equal to 3x square y, and dou v by dou y, if you differentiate this with respect to y, you are going to get over here 3x square. 3x square. So if you look at this value, this would be equal to minus 6x power 4y plus 9x power 4y, which would give me 3x power 4y. Again put the limits 1 comma 1 because he has asked at the point 1 comma 1. So if you say at 1 comma 1, the value of ay would be equal to again 3 units. That means my acceleration vector is becoming 3i cap plus 3j cap units of acceleration. Okay, if it is SI units, it is going to be meter per second square. Now he's asking me numerical answer type question. I'm assuming it is a numerical answer type question because I don't have the exact question with me. So if it is a numerical answer type question, he is expecting the modulus of this thing. So if you think of the mod value of a, it is going to be root over of 3 square plus 3 square. You don't need a calculator for that. The answer would be 3 root 2 units. The answer would be 3 root 2 units. Now if you see, this question was lengthy but not difficult at all. It was slightly lengthy because you were supposed to gather the value of velocity and then proceed forward to acceleration. That way it was lengthy but not at all difficult, and the numerical part also was very easy. You don't require a calculator for this thing. Let us look at the next question. Look at this question. Now this kind of question is a very standard question. You can find even in a book by the name Fluid Mechanics by S.K. Som and Biswas, very standard book. Over there they have used the equation of pressure instead of temperature. If you look at the question, he says it's a 2D unsteady and non-uniform flow. 2x I cap plus x plus 3t j cap is the equation of velocity. Temperature variation is mentioned as 2x square plus xy plus 4t. This is a variation of temperature. He is asking you the time rate of change of temperature is equal to how much. Probably there were some options given. I do not have the options with me. So with whatever data I am having, I am going to make use of it and get the answer. How do you move further with this thing? You realize over here temperature happens to be a function of how many things? Temperature is a function of x, y and t. X, y and t. This is a mathematical question now. If temperature is a function of x, y and t, I can say dt has to be equal to dou t by dou x times dx plus dou t by dou y times dy. Likewise plus dou t by dou small t times dt. Okay. Now I want rate of change of temperature with respect to time. So that means I want over here dt upon dt. That would be equal to how much? It would be equal to dou t by dou x times dx by dt plus dou t by dou y times dy by dt plus dou t by dou t times dt by dt. I have a habit of calling the partial derivatives as dou. Some of you might call it as dabba also. Okay, it's same thing. Now if you observe over here, dx by dt has to be equal to u, dy by dt has to be equal to v, dt by dt would cancel off. Now this is something like an equation of acceleration, okay, or material derivative you can say. So we get the equation ultimately as dt upon dt is equal to dou t by dou t plus u dou t by dou x plus v dou t by dou y. This is the equation we are having. Chaliye, let us get the values now. Dou t by dou t. First of all, partial derivative with respect to time. If you look over here, the partial derivative with respect to time would be 4. It is going to be equal to 4. So I can say this is equal to 4 plus u is equal to 2x. So I'll write in place of u as 2x. In place of u, I'll write 2x. Dou t by dou x is equal to how much? If you look at dou t by dou x, it is going to be 4x plus y. It is going to be 4x plus y plus the value of v is equal to x plus 3t, x plus 3t multiplied to dou t by dou y is equal to x into x. If you simplify this thing, you are going to get 4 plus 8x square plus 2xy plus x square plus 3xt. Further, you can simplify this and you can say the rate of change of temperature with respect to time should be equal to 9x square plus 2xy plus 3xt plus 4. Now what I understand is he must have given find the value of rate of change of temperature with respect to time at so and so location xy and so time t. Now since I did not get the idea of what x and y and what time it is, I'll leave my solution up till here. If you remember what are the coordinates of x, y and time they have mentioned in the question, you can move further, substitute those values, get the exact value of dt by dt. The units of this, if it is SI unit, it is supposed to be Kelvin per second. Moving further, these two questions were from kinematics, very fundamental questions. In a way, both the questions were dealing with acceleration, because you see this equation is something similar to acceleration, okay, material derivative equation. One more question was asked. This question was from the concept of drag and lift, specifically from the concept of Stokes' law in drag and lift. Let me give it a read. The question reads that a ball of density 11,000 kg per meter cube is moving down in a viscous fluid at a constant velocity. The diameter of the ball is equal to 0.1 mm. The fluid viscosity is equal to 1.1 into 10 power minus 3 Pascal second. SI units are mentioned. Take the value of acceleration due to gravity as 10 meter per second square. The velocity of the ball would be equal to how much? As a matter of fact, there was some more data in this question. He had mentioned that consider the value of coefficient of drag as 24 upon Re. Consider the coefficient of drag as 24 upon Re. He also mentioned neglect buoyancy effect. So force of buoyancy you are supposed to neglect. So please treat this also as a part of the given data. Now using this, we have to identify the velocity. Now concentrate on this part. What is this part telling you? CD is equal to 24 upon Re is letting you know that Stokes' law is valid. If Stokes' law is valid, basically he's asking you regarding terminal velocity. If you know the formula for terminal velocity, fine, you can go ahead. If you don't know, it would hardly take 1 or 2 minutes to develop the formula for terminal velocity. Okay. Let us say the value of terminal velocity V is equal to 1 by 18 mu density of the solid body, in this case it is ball, minus density of the fluid multiplied to g times d square. This would be the equation of terminal velocity. In the case Stokes' law is valid. Okay. If he says neglect the force of buoyancy, that implies I am supposed to leave aside density of fluid. Okay. This is going to come when you are having fluid force of buoyancy also involved. Now since he is saying neglect it, I will leave it aside. Now you put in the numbers. Density of the ball, over here it is 11,000 multiplied to G is equal to 10. Diameter over here is 0.1 mm, that is 10 power minus 4 whole square. whole divided by 18 times mu. Mu is equal to 1.1 into 10 power minus 3. 1.1 into 10 power minus 3. Everything is in SI unit. You are supposed to get the answer also in SI unit. They had given some options. I could not write them over here. One of the options over there was 1 by 18, and that exactly is the value in meter per second. 1 by 18 meter per second is the answer. I am expecting this question to be of 1 mark only. Okay, it was a very simple question, so I would think it was a 1 mark question. If you do not remember the equation of terminal velocity, what you could do is you can develop the equation by saying, let us say there is some viscous fluid. In this viscous fluid, you are having a ball settling down. So the forces acting on this ball are W over here, drag force over here. If I'm neglecting the buoyancy effect, I'm going to leave aside that FB upward, leave it aside. I can straight away say W is equal to drag force. W value is equal to how much? It is equal to density of the ball multiplied to G multiplied to volume of the ball, that is pi by 6 d cube, has to be equal to drag force. Drag force is equal to CD, which is 24 by RE multiplied to area. The projected area for a ball would be equal to pi by 4 d square, okay, multiplied to half density of the fluid times d square, half rho v square, sorry, rho v square, half rho v square, half rho v square. If you solve from here also, you will get the same answer. You can try it once. If you solve from here, again you would get the value of velocity as 1 by 18 meter per second. Okay? The concept involved over here is during terminal velocity conditions, the body must be in equilibrium. Therefore, the downward thrust and the upward thrust both should nullify each other. So these were the questions we have got from our students for fluid mechanics subject. I understand the questions were not difficult at all. I would treat them as easy questions. One question probably, which is temperature variation, was slightly moderate kind of question. Otherwise, they were easy questions only. The first question was slightly lengthy though, but still it was an easy question. Thank you. I will now invite my colleague Malkonde sir to take further. Thank you, sir.
Hello dear students, welcome to the thermal part. I am Malakondaya. Thermal faculty in ACE Engineering Academy. Dear students, as per the student database, total 7 questions asked from thermal science. Out of 7 questions, 4 are 2 marks questions and 3 are 1 mark questions. But as of now, we have received 5 questions from the students. Now, let us discuss those 5 questions. Let us take the very first question. Look at the very first question. It is asked like this. Clausius inequality is valid for. As we know, the Clausius inequality equation is cyclic integral del q by t always less than or equal to 0. Cyclic integral del q by t is equal to 0 for a reversible cycle. For a reversible cycle. Whereas cyclic integral del q by t less than 0 for irreversible cycle. For irreversible cycle. Dear students, believe me, cyclic integral del q by t greater than 0 is impossible. Is impossible. And as we know, the symbol cyclic integral is used for only thermodynamic cycle. Anyhow, the Clausius inequality equation is valid for both reversible cycle and irreversible cycle. Once again, cyclic integral del q by t equal to 0 for reversible cycle, cyclic integral del q by t less than 0 for irreversible cycle. It means once you construct a heat engine, your heat engine must be satisfying the Clausius inequality equation. After you construct the practical heat engine, you have to compare your practical heat engine is satisfying the Clausius inequality equation or not. If your practical heat engine is maintaining cyclic integral del q by t greater than 0, your practical heat engine never be practically existing. That is the beauty of Carnot cycle, or that is the beauty of Clausius inequality equation. The Clausius inequality equation will be deciding whether your practically constructing engine can exist or not. Now look at the options. Only reversible cycle, not only reversible cycle. Reversible cycle, okay, only reversible cycle, not correct. Only irreversible cycle, only is not correct. Any cycle, yes, absolutely correct. The Clausius inequality is applicable for both reversible cycle and irreversible cycle. Therefore, option C is absolutely correct. I hope all of you clearly got my point. Shall I take the next question? Yes. Look at the next question. It is asked from the first law of thermodynamics, given like this. Work done in polytropic process with some data given, P1 given, V1 given, V2 and index of polytropic process, that is polytropic index given. By looking the initial volume V1 and final volume V2, you can come to know what kind of process is for this data. Since the volume is reducing from 5 meter cube to 2.5 meter cube, that volume reduction is possible only by compression process. Therefore, this problem is connected to a compression process. Now, let me project the PV coordinate system, pressure versus volume coordinate system for the given data. The polytropic process may be represented like this. Polytropic process may be represented like this. This is the 1 to 2 polytropic compression process. The slope of this curve is minus Np by V. Minus Np by V. This process is following by a rule called polytropic law, PV power n equal to constant. PV power n equal to constant. Finally, you are asked to decide the polytropic work. What is the polytropic work done? Polytropic work done for a closed system, that is non-flow polytropic work, is equal to P1 V1 minus P2 V2 divided by n minus 1. Here we know the P1 value, V1 value, V2 value. Unknown value is P2. You need to decide the P2 value by applying the polytropic rule. The polytropic rule is PV power n equal to constant. It means P1 V1 power n is equal to P2 V2 power n, because PV power n equal to constant is the polytropic rule. You know P1 V1 n value, V2 value also known. From this you can find the P2 value. You put all these values here for getting the P2. I have decided the P2 value 252.713 kilopascal. Then you substitute all the values for getting the polytropic work done. The polytropic work done, what I got is minus 408.9125 kilojoules per kilogram. Look at the work done. Work done I got negative. Negative work means work done on the system. The thermodynamic sense is that if the work transfer is negative, that is the work done on the system. If the work transfer is positive, that is work done by the system. Here work done on the system means the system is coming under power consuming device. That means the data is given for power consuming fellow. I hope all of you clearly understood. Shall I take the next question? Yes. Look at the next question. It is asked like this. A wall of thickness 0.1 meter, the higher temperature on the left surface of the wall is 80 degrees centigrade and thermal conductivity is 15 watts per meter Kelvin. The heat transfer through the wall is 4500 watts per meter square. The rate of entropy generation per unit area is how much? Dear students, this is the problem combined with heat transfer and thermal science. Here it is asked to find the entropy generation, but thermal conductivity is given for deciding the final temperature or the temperature of the wall on the other side. It is like this. Let us take the wall. This is the inner wall, inside wall, outside wall, outside wall. It is given that inside wall temperature is 80 degrees centigrade. Outside wall temperature, let that is T2 is not given. But the steady heat transfer rate or the steady heat transfer per unit area given, the heat transfer per unit area is given 4500 watts per meter square. 4500 watts per meter square. And the thickness of the wall thickness is generally denoted by dx. That wall thickness is given, dx is given 0.1 meter. And thermal conductivity is given 15 watts per meter Kelvin. 15 watts per meter Kelvin. That is the data. First you have to decide the other side wall temperature, because the entropy generation equal to minus Q by higher temperature of the wall plus Q by lower temperature of the wall, because here the higher surface temperature is losing the heat energy, whereas low temperature surface is receiving the energy. Thermodynamic sense is that if the heat is received by the surface, that kind of heat transfer is positive heat transfer. If the heat is lost by a surface, that kind of heat transfer is negative heat transfer. Since the surface which is maintaining 80 degrees centigrade is losing the thermal energy, therefore with respect to the surface maintaining 80 degrees centigrade, the heat transfer is negative. Minus Q by T1 plus Q by T2 be the entropy generation. From this, the unknown value is T2. That T2 can be decided by like this. Heat transfer Q equal to K into A into dt by dx. dt by dx can also be written as K into A into the hot surface temperature minus cold surface temperature divided by dx. From this, Q by A is given, the Q by A is given 4500 watts per meter square. 4500, it is equal to K into, K is given I think it is 15, K is given 15 watts per meter Kelvin. 15 into T1 80 minus T2 is unknown value divided by Tx 0.1 meter. From this T2 can be found. After finding the T2, then you decide the entropy generation. S generation equal to minus Q by T1 plus Q by T2 plus Q by T2. एक minute. Q by, should be very careful while we are discussing in a limited space, Q by T2. Here T1 equal to 80 plus 273. The T1 and T2 should be in absolute temperatures. 80 plus 273 and T2 value, the T2 value I got is 50 degree centigrade, 50 degree centigrade, 50 plus 273, 50 plus 273. Then you substitute all the values. The heat transfer per unit area for getting the entropy generation, I got the entropy generation for U is 1.184 watts per meter square Kelvin, since the heat transfer is in watts per meter square. I hope all of you clearly understood. Now let us take the another question from the IC engine, from the Otto cycle. Look at the very first cycle problem. You know, among the all practical cycles, Otto cycle is the first practical cycle. Let us read the problem clearly, because problem reading is very, very important. Once you read the problem clearly, it is very easy for you to have the analysis. Try to read the question to know what is given and what you are asked to decide. It is given like this. For an engine working on Otto cycle has displacement volume. Here displacement volume means piston displacement volume. Piston displacement volume we are pronouncing as swept volume. That swept volume is given 250 centimeter cube, cubic centimeters, and clearance volume is given 37.5 centimeter cube. Clearance volume VC equal to 37.5 centimeter cube. Okay, centimeter cube. The pressure and temperature at the beginning of the compression process are 100 kilopascal and 300 Kelvin. Pressure at the beginning of the compression, generally marked with P1, is equal to 100 kilopascal, whereas the temperature at the beginning of the compression, T1 equal to 300 Kelvin. 300 Kelvin. Heat transfer during the constant volume heat addition process is 800 kilojoules per kg. The heat transfer or heat supplied during the constant volume process is 800 kilojoules per kilogram. The specific heat at constant volume given, CV, and adiabatic index, gamma also given. You are asked to decide the maximum pressure in the cycle. To decide the maximum pressure in the cycle, it is better to construct the PV diagram for Otto cycle. If I take the pressure versus volume coordinate system for the constant volume cycle or Otto cycle, the Otto cycle consists of 4 processes. 2 are isentropic process. 1 to 2 is the isentropic compression process. 2 to 3 constant volume heat addition process. 3 to 4 isentropic expansion process. 4 to 1 constant volume heat rejection process. That is the PV diagram for Otto cycle. From this cycle, you can decide at what state the cycle is maintaining maximum pressure. The pressure at state 1 is P1. The pressure at state 1 is P1. Pressure after compression is P2. The pressure after heat addition at constant volume is P3, and P4 be the pressure after isentropic expansion process, P4. From these 4 pressure limits, you can decide the highest pressure or peak pressure. The peak pressure is P3. Indirectly, you are asked to decide the maximum pressure P3. For that, here it is given, P1 given, T1 given, the heat supplied also given, heat supplied during the 2 to 3 process given, and 2 to 3 process given, the heat supplied is given, the heat supplied also given, and the volume before compression is not given. Of course, the swept volume given. Swept volume equal to, this is the total volume of the material present in the cylinder. This is the total volume of the material present in the cylinder, can be marked as V1. This is the clearance volume. This is the clearance volume. V2 equal to Vc. Of course, V2 equal to V3. Then this is the piston displacement volume. The difference between the total volume of the material inside the cylinder and clearance volume is the piston displacement volume. Here piston displacement volume given, the piston displacement volume 250 and clearance volume 37.5. 250 centimeter cube and clearance volume Vc is given 37.5 centimeter cube. Of course, specific heat at constant volume given, adiabatic index gamma also given. Initial pressure, temperature given. Now first let us take the very first process, that is isentropic compression process. For the isentropic compression process, the rule is PV rest, PV power gamma equal to constant. If PV power gamma equal to constant, I can write that P1 V1 power gamma equal to P2 V2 power gamma. From this, the volume after compression or pressure after compression, let us find the pressure after compression directly. Pressure after compression P2 is equal to P1 into V1 by V2 power gamma. But you don't know the V1 value. V1 equal to what? From this diagram, V2 plus Vs. Here Vs is given, Vc is given, this Vc itself is the clearance volume. Then what is the total volume of the material present in the cylinder? Total volume of the material present in the cylinder is clearance volume plus swept volume. Clearance volume plus swept volume. You know the swept volume, you know the clearance volume, V1 can be found. And V2, the clearance volume itself is the V2. Clearance volume itself is the V2, that is 37.5 centimeter cube. You know the V1 value, V2 value, P1 value, gamma value given. From this you can decide the pressure after compression process. That pressure after compression process I got is 1731.6 kilopascal. I hope you are all clearly following. Similarly, you can find the temperature after compression process by applying the temperature volume relation for isentropic process. For the isentropic process, temperature volume relation is T2 by T1 equal to V1 by V2 rest gamma minus 1. You know the V1 value, V2 value, T1 value. From this you can decide the T2 value. This T2 value I got is 677.596 Kelvin. I hope you are all following. Now let us take the 223 constant volume heat addition process. For the 223 process, volume remains constant. Generally we are taking air as the material for Otto cycle. Air is coming under one of the ideal gases. For any ideal gas at constant volume, pressure is directly proportional to temperature. Since pressure is directly proportional to temperature for the constant volume process 223, I can write that P2 by T2 is equal to P3 by T3, because P by T is proportional to 1 or P by T equal to constant. From that I can write P2 by T2 equal to P3 by T3. From this you can decide the P3 value. But the problem is T3 is unknown value. That T3 temperature after heat addition to be found for finding the P3 value. But what is the heat supplied formula? Heat supplied at constant volume during the 223 process is change in internal energy of the material, that is Cv into T3 minus T2. From this, the T3 equal to heat supplied during the 223 process divided by Cv plus T2. We have the T2 value, heat supplied is given, Cv given. From this you can find the temperature after heat addition process. That temperature after heat addition process I have found for you is 1791.7 Kelvin. Then for finding the temperature pressure after heat addition process, you are asked to decide the maximum pressure. The maximum pressure after heat addition P3, that P3 can be found by using the constant volume relation. At constant volume during the 2 to 3 process, P2 by T2 according to Charles law or constant pressure law, P2 by T2 equal to P3 by T3. From this you can decide the pressure after heat addition process. That is the maximum pressure you can expect from the Otto cycle. That maximum pressure I got is 4578.71 kilopascal. It can be also written as 45.7871 bar, because 1 bar equal to 100 kilopascal. I hope all of you clearly following. Let us take the last question. The last question is, look at the last question. Array, 1 minute. Look at the last question. It is asked like this. For a reheat Rankine cycle, the work output of high pressure turbine is 400 kilojoules per kg and low pressure turbine is 850 kilojoules per kg. Work given by the high pressure turbine is 400 kilojoules per kg, whereas work energy given by low pressure turbine is more than that of high pressure turbine, that is 850 kilojoules per kg. Okay. If the pump work is 15 kilojoules per kg, cycle efficiency is 32%. Thermal efficiency of the cycle is given 0.32. Then the amount of heat rejected in the cycle in kilojoules per kg will be. Very simple problem. Though it is given for 2 marks, it is very simple problem. According to first law of thermodynamics, whenever a system is executing in the cyclic manner, the cyclic integral del Q is equal to cyclic integral del W. Cyclic integral del Q equal to cyclic integral del W. That means net heat transfer is equal to net work transfer. Here cyclic integral del W means net work transfer. That net work transfer is equal to work energy given by the high pressure turbine plus work energy given by the low pressure turbine minus pump work, because the fellow pump is coming under power demanding device. Here you know the work energy given by the high pressure turbine, work energy given by the low pressure turbine, pump work. These two works are positive works because turbine is coming under power generating fellow, whereas pump is coming under power consuming fellow. From this you can decide the net work from the Rankine cycle. Dear students, remember Rankine cycle is also coming under one of the thermodynamic cycle. From this, the net work what I am getting is 1235 kilojoules per kg. But according to first law of thermodynamics, cyclic integral del Q equal to cyclic integral del W. It means net work transfer is equal to net heat transfer. The net heat transfer equal to heat supplied minus heat rejection is equal to net work transfer. This net work transfer I got is 1235 kilojoules per kg. From this you can decide the heat rejecting from the cycle equal to heat supplied minus net work from the cycle. But heat supplied is not given in the problem. For finding the heat supplied, let us take the thermal efficiency formula for the Rankine cycle. Thermal efficiency of the Rankine cycle is equal to ratio between the output and input. The output from the Rankine cycle is net work output. Ratio between the net work output and heat supply to the system. Here net work output is found 1235. Thermal efficiency is given 0.32. Thermal efficiency is given, look at the value. Thermal efficiency 32%, 0.32. From this I can decide the heat supplied to the system. The heat supplied to the system equal to net work divided by thermal efficiency. This heat supplied I got is 3859.375 kilojoules per kg. Now we know the network value and heat supplied value. From this you can decide how much amount of heat is rejecting from the thermoelectric power plant or Rankine cycle. The value is 2624.375 kilojoules per kg. That is the answer for this particular problem. I hope all of you clearly understood. Now I am ending my session. My friend Devendra will handle the heat transfer. Please.
Good evening everyone. So hope you are well. So you know very well, so in the morning session the heat transfer weightage purely 8 marks and one question combinedly with thermodynamics. So we are not considering that weightage. So from heat transfer 8 marks are there. In that 2 questions are very lengthy and you know very well today we are discussing memory based questions. So that's why that lengthy questions students are unable to recollect. That's why we are solving some few questions and very soon when the actual question paper is available I will give you the correct solution. Let us move to the first question. This question, when the question came, students afraid by looking at this, but believe me, question is very simple and most of the students got the right answer because as you can see a two-dimensional momentum equation for natural convection is given by. So this question from free convection. So equation is given, in that what they wrote, the form G beta T minus T infinity represents and options are there. So those who already know heat transfer, beta means coefficient of volume expansion. So as you know, in this question G beta T minus T infinity, what does this term represent? So beta unit is 1 by Kelvin, this is temperature difference, Kelvin, right? So this is 1 by Kelvin and Kelvin, so this get cancelled out. So this terminology, acceleration due to gravity, meter per second square. The unit of G is meter per second square. As you can see, force is equal to mass into acceleration. So F by M is equal to acceleration, that is unit is meter per second square. So meter per second square you can write like a force per unit mass. So as you can see, option A is a ratio of inertia to the viscous. Ratio of forces, so it is no unit. So this is cancel out. Second, the ratio of buoyant force to the viscous force, this is also dimensionless, not correct. Next, viscous force per unit mass and buoyant force per unit mass. But as you can see, this is G, acceleration due to gravity, and coefficient of volume expansion, which can measure the change in density with respect to temperature. So as you know, gravity and the density difference will give you the buoyancy force. So that's why this is density difference with respect to temperature and this is acceleration due to gravity. This combined together will measure the buoyancy force. That's why you need to go for this option. So the right answer is D. Hope most of the people got the right answer, that is buoyant force per unit mass. Very simple question, 1 mark. Next, there is a question which looks to be lengthy but very easy. Almost everyone got the right answer. See, in an open heart surgery, the blood of a patient is cooled down from 37 to 25. So it is cooled down. So hot fluid So we will take TH1, that is 37 degrees Celsius, TH2, that is 25 degrees Celsius. Using concentric tube counterflow heat exchanger, make sure that it is counterflow heat exchanger, using water which enters at 4 degree. So it is a cold, that is water, right? So TC1 is equal to 4 degrees Celsius and TC2 is 18 degrees Celsius, right? The blood flow rate is 5 liter per minute. Calculate the effectiveness of the heat exchanger. So make sure that in this we need to find effectiveness. The fluid properties are given. So make sure that in this problem they asked to find out the effectiveness. Now before going to that, what is the most important thing? If you see the temperature difference here, so it is 37 minus 25, okay, 37 minus 25. So this difference is a 12, right? In this case it is 418. So this is 14. This is 14, right? So as you can see, the hot fluid temperature vary by 12 degree and cold fluid temperature vary by 14 degree. So which fluid have more temperature difference? It is hot fluid. That's why remember delta T of cold is greater than delta T of hot. So what you can say? You can say minimum heat capacity rate is cold. Cold is a minimum heat capacity rate. So effectiveness, what is effectiveness? That is Q actual by Q max. So what you can do? You can write m dot C Cc Tc2 minus Tc1 by C minimum Th1 minus Tc1. No need to explain how this formula came. Everyone knows that. So here you can write Tc2 minus Tc1 by Th1 minus Tc1. So Tc2 is 18 minus 4 this one, Th1 37 minus 4. So this is 14 by 33, right? So if you calculate this, you will get 0.424. So this is the right answer based upon memory. Whatever I got, I have this question. According to this question, so answer is 0.424. No need to go for capacity ratio or NT or something like that. This is the easiest way to solve this problem. Most of the people got the right answer because it's very easy. Similar question you will get in the P.K. Naxar book. It is already solved. Next, this is the memory based question. Please take care of this. Radiation of 600 watt per meter square incident on a plate, okay, where sigma 5.67 into 10 raised to power minus 8, of course unit is watt per meter square, k to the power 4. Temperature of air is 25 degrees Celsius and emissivity of the plate 0.21. The temperature of the plate in degrees Celsius at equilibrium is. So simple question, simple. So there is a plate, that emissivity of this plate is 0.21. So on this plate there is a falling of energy, we call it as irradiation, that is 600 watt per meter square. Surrounding temperature, that is 25 degrees Celsius, which is nothing but 298 Kelvin, right, which is nothing but 298 Kelvin. Next, so the temperature of the plate at equilibrium. So what is the temperature of the plate at equilibrium? At equilibrium what will happen? Whatever Q in is equal to Q out. Of course, if this plate is maintained constant temperature, so whatever Q in is equal to Q out. So apply that, Q in is equal to Q out. Of course, area is same from both the sides, so I am writing per unit area. So here it is G. How to calculate Q out? It's a plate kept in a surrounding fluid. So this is the case of small body kept in a large enclosure. That's why epsilon sigma Ts raised to power 4 minus T infinity raised to power 4. Make sure that area get cancelled out from both the sides. So this is 600, emissivity 0.21, this is 5.67, 10 raised to power minus 8, this is Ts raised to power 4 minus 298 raised to power 4. Okay, so simple. If you calculate this, roughly you will get 491 Kelvin, roughly, okay, roughly. But make sure that this is the answer in Kelvin. But suppose if the temperature of the plate asked in degree Celsius, minus 273, you do it. If you do it, then you will get roughly 218 degree Celsius. Make sure that this is memory based question. So whatever data is available, based upon that, you will get this answer. So these are the three simple questions. Remaining questions are there which is very lengthy, where students are feeling difficulty. Don't worry, once I get the actual paper, definitely I will give you the correct solution. So please wait for some days. Now this is about the heat transfer. Now the most weighted topic is production by first seek answer. So I will introduce first seek answer to take care.
Right, sir. Very good evening. So let's continue production engineering questions. As usual, one of the highest weighted subject ever in an entire mechanical paper. This time around, there are 15 marks, 5 1-mark question, 5 2-mark questions were there. So out of which few questions I will deal and few questions my colleague faculties will deal. So let's start. So the first question, I think it's a 2-mark question. Now, if you read the question, they said a cylindrical bar of 100 mm diameter is orthogonally straight turned with a cutting velocity, and the depth of cut 1 meter per minute is cutting velocity and the depth of cut is 1 mm respectively. The specific cutting energy of the work material is given 6 joule per mm cube. Neglect the contribution of the feed force towards the cutting power. They are asking power required in a watt. Sir, such a simple question that no need of even calculator. I will solve this question. Simply first of all put a formula, simplify the formula. At the end, as everyone know, pi value, that is 3.14159. If you are able to remember at least 5 decimals, so with that I am able to give the answer, sir. No need of even calculator. Observe. Whereas I notice many given the solutions in a different approaches. Observe here this question. It is for 2 marks. Whereas when they said straight turned cylindrical bar of 100 diameter, so diameter of the workpiece is 100 mm. Orthogonally turned, cutting velocity is given, but instead of mentioning cutting velocity, I think they mentioned feed rate. So here data you cross check, but they mentioned feed rate, it seems. 1 minute. So that is 1 meter per minute. Sir, all are memory based question, be careful. And depth of cut is equal to 1 mm. Specific cutting energy is given, that is U, that is equal to 6 joule per 6 joule per mm cube. Neglect the contribution of feed force, they are asking cutting power. Sir, you know, whenever specific cutting power is given, that is nothing but the 6 joule per mm cube, whatever value, it is always power upon MRR. That's it, cutting power by metal removal rate. Whereas they are asking cutting power in watt. Now, cutting power is nothing but 6 into metal removal rate. See, whatever may be the operation, when they said orthogonal machining, we can write metal removal rate as FDV. Whereas cutting velocity is not given, but I can write it as F into D into V is nothing but pi capital D into N. Whereas in this particular data, this F into capital N together is the feed rate. So this Fm whatever I wrote, that is nothing but indirectly F into N only, but it is in meter per minute. Whereas depth of cut, see, it is basically a tube of 1 mm thickness this side. Here depth of cut they might have wrote here, but a tube of 1 mm thickness this side. So cylindrical tube of 1 mm thickness whenever it is mentioned, so the depth of cut is nothing but thickness only, because orthogonal turning. Na? So again you can draw that particular figure of orthogonal turning where depth of cut is nothing but a thickness of the tube. Therefore, F into N is given as 1 meter per minute. I can write that into mm per second as 1000 by 60. It will be in a mm per second. Into small d is basically they mentioned it is a thickness, sir. In the question it is a thickness. So that will become small d into pi into capital D is the diameter, that is 100. So if this much data you have, simply substitute this, don't calculate here immediately. Simply substitute this in this particular formula, 6 into, that is provided as the specific cutting energy 6 joule per mm cube into what is MRR now? MRR is nothing but enter this fraction. So that is 1000 by 60 into 1 into pi into 100. Now simplify this, sir. 6 tens are 60. So here in denominator there will be a 10 now. In the numerator you have a 1000 value and another is 100 value and the pi. So this 0 and this 1 0 will gone. So 1000 into 10 will be a 10,000 into pi. So those who know 10,000 into pi, pi is nothing but 3.14159. If you are able to remember at least 5 4 decimals. Even if it is not, 3.141 is also sufficient. I can go up to the 5th decimal also. So you can write here it as 31415.9, that is in a watt. Cross check the unit, but they are asking in a kilowatt actually. It is they are asking in a kilowatt. So that it will be a 31.41 kilowatt. So obvious that the range they will provide as it's a numerical answer type. So the range will be 31 to 32 they will give obviously. So answer is for the power it is 31.41 kilowatt. One of the easiest and simple method, whereas some used to solve by considering a tube, outer dia, inner dia difference they don't know, they will say area calculation, pi dt, all that is unnecessary it seems. Very easily without even calculator you can proceed and you can give the answer here directly. That is question number 1. If you go to the next question, one of the question from the metrology, very easy. Sir, whenever metrology related question you have, I used to mention always that take a paper, first draw the fit diagram. As I mentioned, 25 is the basic size for the shaft. And upper and lower limits are, if you notice, it's equally bilateral, right? But it is for the shaft. Plus 0.01, minus 0.01. Whereas whole basic size is different from the shaft basic size. Still not an issue. Change the basic size position after drawing the fit diagram. Whereas if you notice basic size 25.015, obviously it is much above than 25, even much above than the upper limit of the shaft, because upper limit of the shaft is 25.01 only. So here whole basic size, what is that? 25.015. Even if I shift it, then I can write upper and lower limit differently. Still, if you notice, upper and lower limit, both are equally bilateral. So when you are drawing the tolerance zone for this particular hole, the tolerance zone of the hole will look like something like this. As per the given data, it is plus 0.015 and this is also plus 0.015. If I shift this basic size to the 25 also, then to the same basic size, tolerance zones of hole and shaft are overlapping. Whenever there is an overlap of the tolerance zones, then simply answer is it's a transition fit. Why? Because sometime it give clearance fit and sometime it will give interference fit. When I consider upper limit of the hole, hole become larger than shaft, whereas when I consider lower limit of the hole and upper limit of the shaft, then shaft become larger than hole. Because of that reason, it's a transition fit. One of the easiest and simple question. Whereas one more question where I taken simply a data and they are asking you to calculate cutting force FC. So if you notice the data, cutting speed is given in a 4 meter per second, orthogonal rake angle is given 5 degrees, and then uncut chip thickness is given T1.2 mm, whereas width of cut is given 3 mm, friction angle is given beta 45 degree, shear angle is given 5, that is 25 degree, shear strength of the workpiece tau is also given, that is 1000 megapascal. And what they are asking? Cutting force. Sir, you know, from the merchant circle diagram, those who gone through the merchant analysis, very easy question for the 2 marks. Cutting force is equal to FC is equal to R cos beta minus alpha. Whereas in this question, in this particular equation, except capital R, that is resultant force, remaining every data is provided. But I need to find out resultant R. So how to get? To get the resultant, the remaining data help us. So that whenever in the question you have a shear strength, it means that indirectly they are asking you to calculate a shear force. From that shear force, you are going to get the resultant R. So what is a shear force FSR? Shear force FSR, I can write from the merchant circle once again that R cos phi plus beta minus alpha. So from here I can get a resultant R. But what is shear force? Shear force Fs, I can write that is also as equal to shear strength into shear plane area, tau into S. So that when I equate these both things, then I can write as 1000 into shear plane area, that is nothing but again, we can write WT1 by sin phi. Whereas everything is provided, sir. Width of chip is provided, that is nothing but 3 mm into uncut chip thickness is provided, that is 0.2. Capital R is equal to tau S into AS. AS is nothing but W into T1 by sin phi. What is phi? Phi is provided as a 25 degree. This is what tau into AS. But along the tau into AS, in the denominator, I will be having a cos phi plus beta minus alpha. What is phi? Phi is a 25 plus beta. What is beta provided? Beta is a 45 plus minus 45 cos phi plus beta minus alpha. This is minus that is 5 degree. Therefore, this value will become, I already solved, the value of capital R will be 3359.34 Newton. You cross check the units, it will be a capital R. Once you got the capital R, substitute, then cutting force FC will become 3359.34 into cos beta minus alpha. Beta is a 45 minus alpha is a 5 degree. Therefore, the answer to this question is 2573.4 Newton. Sir, cross check the units carefully, then it is very easy to solve the questions from the production. As these are a few questions from the production of the morning session. So remaining will be continued by my colleague faculty Madhushekar sir. Please sir.
Marker. Right. Okay. Now here I am going to deal with material science and metal forming questions. Right. So from the material science, 2 questions they asked. All these 2 questions were directly a simple questions we discussed in the class also. Now this question here it is, the question is related to heat treatment. Which of the following heat treatment process is applied for steel to increase the surface hardness? Now see here, cyaniding process is also applied to increase the surface hardness, nitriding process also is applied to increase the surface hardness, and also carburizing and nitriding, we can say carbonitriding process also we can by using this process also we can increase the surface hardness, but annealing process is not used to increase the surface hardness. So it's an MSc question. So A, B, C, all these three are correct. Okay, now all these three are correct. Now the next question, here it is, this question is from the iron cementite phase diagram that is related to lever rule. So in this question what they are asking, the mass fraction of pro-eutectoid ferrite, mass fraction of pro-eutectoid ferrite in an iron carbon alloy which is having some 0.5 weight% of carbon, right. So simply in a simple way I will explain this one, okay. So here it is not exactly, we do not know the data, so I am assuming the temperature, I am considering it as like just below the eutectoid temperature, like 727 degrees Celsius, okay. In case if the temperature is given, then based on that you should consider, right. So I am assuming here temperature is just below the eutectoid temperature. So just below the eutectoid temperature or at eutectoid temperature, this is C0, this is some 0.5% of carbon. Then 100% of alpha iron is present here, that is C alpha, 100% of perlite is exist here, C perlite. So this is the lever line. Now the lever line here it is, this side is alpha, this side is perlite. So at this point we should find the mass fraction of pro-eutectoid ferrite, 0.5% of carbon here it is given. So C alpha is 0.025% of carbon. So 100% of perlite is exist at approximately 0.8% of carbon. This is the lever line we discussed number of times, right. So now mass fraction of pro-eutectoid alpha I want. So from this, so by considering opposite half of the line Cp minus C0 by Cp minus C alpha, that is some 0.8 minus 0.5 by 0.8 minus 0.025, by solving this you will get approximately 0.387. So very simple question, this is 2 mark question, very simple calculation based question, by using lever line we will get it there, right. This is one question. Now next one more question, this question actually from metal forming, a rolling operation, it is also formula based question. Simple, if you know the formula I will get the answer easily. Now see here, in this question the data, what is the data given here? In this question the data given, initial thickness is given H0, that is 4 mm. Right, in a single pass rolling mill having a roll diameter is given here, roll diameter is given, I am assuming it as a diameter that is 200 mm because it is a memory based question, right, based on the question I am going to discuss, right. And the strip width is given, that is 100 mm, this is the width, strip width is given. Average coefficient of friction is given, that is mu, average coefficient of friction mu is also given. If the flow stress in a plane strain of the strip is sigma is equal to 207 into 414 epsilon, okay, flow stress is given, flow stress equation is given 207 plus 414 into epsilon. In case in the question if it is given average flow stress, now directly by substituting epsilon value, true strain value, you will get the average flow stress. But in the question it is given simply flow stress. So if you want to calculate average flow stress, okay, if you want to calculate average flow stress, you should consider flow stress at 0 strain and flow stress at epsilon by 2. Now and also in this question H0 is given but H1 is not given. So but in the question what is given, maximum permissible draft is given, okay, maximum permissible draft. If we consider maximum permissible draft, delta H is equal to mu square R, okay. So from this calculate HF, that value will get approximately some like 1 mm, okay na. Then after that calculate true strain, that is ln H0 by H1, it is actually, sorry, it is, you will get approximately 3 mm, I think, H1. H1 is 3 mm you will get. So calculate from this true strain, that is some 0.2876 epsilon. Then flow stress at 0 strain, that is equal to 207 plus 414 into 0, and flow stress at strain is equal to 0.2876, that is equal to 207 plus 414 into 0.2876. Calculate both and take the average flow stress. So I am considering from these two, by considering average flow stress, that is epsilon is equal to 0 plus epsilon value by 2, that approximately I will get some 326.06 megapascal. Okay na? Right. Now what is the role separating force? Role separating force equation is equal to 2 by root 3 average flow stress into area width into length of the deformation zone into 1 plus mu L by 4 H average, and H average is nothing but H1 plus H0 by 2, and by substituting the values here, you may get doubt, width is given in the question, length is nothing but length of the deformation zone, that is R into delta H. Right. By substituting the values in this equation, you will get the role separating force that approximately here I am giving based on the data, that approximately I am giving here based on the data, that is 350.28 kilonewton. Actually this question is based on this data, okay. Maybe the data may be different in the main answer sheet, that we will discuss later, but anyhow they are given the flow stress. So based on that you should calculate average flow stress and you should substitute in the simple basic formula, right. Now next one more question, that is from the additive manufacturing, right. One more question, this is recently added in the GATE syllabus, okay na, right. In this additive manufacturing question, what is the question? Which of the following additive manufacturing technology uses wire as a feedstock material? Okay na. Now simple, in a simple way we will get your direct energy deposition method is a 3D printing method, and stereolithography is also a 3D printing method by using nanotechnology, and fused deposition modeling method, in this method we are using a wire, this wire is heated by using an heating element, and this is going to be melted on the surface, and this melted material is going to be occupied on the layer by layer on the material. So here in this case we are using wire as a material, okay, wire as a feedstock. So this is the most appropriate answer. Now here this is also a additive manufacturing method, these two are additive manufacturing method, but in this method, selective laser sintering method, in this method we are doing this additive manufacturing by by converting the material into powder form, and then by using laser energy as a source of energy we are making these additives, so that the most appropriate answer for this question is C. Right. These are some of the questions especially from material science and metal forming, and my colleague Ravi sir will take remaining questions.
Hello students, now we have to see some production question, that is remaining production question here. Yes, you can see the first question is here. The same type of question I taught in expected GATE question 22, it is available, that video is available on YouTube. Now see that question. Yeah, you can see that very easy question. A stepper motor has 600 pulses per revolution. What is that? 600 pulses, or they may use word steps, 600 steps per revolution, means it is a one revolution of motor, one revolution of motor. Now here you can see that the gearbox is not mentioned in this question, hence we can write it here, one revolution of motor is equal to one revolution of lead screw. Yes, then the table will travel by some distance. Just see it, the output shaft of the motor is directly coupled to a lead screw, means no gearbox is there. of a pitch 5 millimeter, means in the 600 pulses, the work table, just see the table will drive by a distance of pitch. Then I am writing here that pitch is 5 millimeter. Yes, how easy? The table moves at a constant speed of 5000 millimeter per minute. Here the table speed is also given. It is 5000 millimeter per minute. Yes, the frequency of pulse supply to the motor in hertz. Just here, hertz. What we have to calculate? The frequency. In any question, I said that what to do? First, calculate basic length unit. Then I am writing here first. How to calculate basic length unit? Now you can see that what are the pulses here? In the 600 pulses, there is a 5 millimeter distance travel. Then I am writing in the 600 pulses, the distance traveled is 6 millimeter by the work table. Then my question is, in one pulse, how much distance is covered, that is BLU? Now do the cross multiplication, that is BLU into 600 is equal to 6 into 1, then we will get the value of BLU here. That BLU will be 6 divided by 600. Just I need to check it data once. Yes, pitch is 5 millimeter. Just see, I need to write here 5 millimeter. 5 millimeter by 600. Then you will get the value of BLU. Yes. Now next, what is the table speed? Now we have to write the formula of table speed. Table speed is equal to BLU into frequency. And we have to calculate the frequency in this question. Now what is the table speed? 5000 millimeter per minute. Millimeter per minute. 1 minute is 60 seconds. Is equal to what is BLU? 5 divided by 600 into frequency. Just calculate that answer. You will get 10,000. 1 by second, that is hertz. This question is over. This question was on NC-CNC machine. Now see the wonderful next question, which is on welding. S6, the welding question. It is almost similar. The same type of question is available in our classroom practice question 11, and as well as in the gate 22 expected question. I taught that question and question number 2 plus classroom practice question 11. Combine that, you will get the answer of this question. Not easy, just see. A weld is made using arc welding process with the following welding parameters. Just see, the current is 150 ampere. Yes, voltage is 20 volt. Welding speed is 5 millimeter per second. Yes, wire diameter means electrode diameter is 3 millimeter. Yes, then specific melting energy, just see, specific melting energy, that is U is given. That is 10 joule per millimeter cube. Heat transfer efficiency of the process is 70%. Heat transfer efficiency is 70%. I am writing 0.70. And melting efficiency is 60%. I am writing melting efficiency is 0.60. Find out wire feed rate, means electrode feed rate. I am writing here F is equal to question mark in millimeter per second, at which filler is 60% in a weld bead. That is the problem. At which filler is 60% in the weld bead. Just see. Filling rate by electrode means electrode is supplying molten metal to the weld bead is equal to filling rate by weld bead. Yes, whatever the electrode is supplying molten metal to the weld bead, the same molten metal weld bead is taking. But here what is the issue? Just see what is the issue. At which filler is 60% in the weld bead. Out of total volume of weld bead, the filler material is supplied only 60%. That's why into 60% means 0.60 we need to write. Now see, filling rate means it is a millimeter cube per second. then what is the filling rate by electrode? Then I am writing the cross-sectional area of electrode into feed. Yes, that feed we have to calculate is equal to filling rate by weld bead. What is that? Area of weld bead into welding speed. This is for weld bead and this is all for electrode. Yes, that is here. Now see how to tackle with this question. This is A is given. Yes, it is given. F we have to calculate. Yes, now see how we can proceed. Yeah, then I am writing cross-sectional area is pi by 4 d square, diameter is 3 square, into F we have to calculate. This area we don't know. Into this welding speed it is given 5 millimeter per second. Then I am writing here 5. Yes, how to proceed with this question? Now see the number of efficiency as given. We have the formula of melting efficiency is equal to U A V divided by eta Vi. Put all the values here. Yes, what is melting efficiency here? It is given 0.6 is equal to what is U? 10. Area we have to calculate into what is this welding speed? Here we have that 5 divided by this efficiency, heat transfer efficiency is 0.7 into what is V and I? 20 into 150. Here we are getting the answer of area, that is 25.2 millimeter square, and that area is of area of weld bead. Yes. Now what to do? Just see that equation you need to write here again. Then I am writing pi by 4 into 3 square, that feeder rate we have to calculate is equal to area of weld bead, that is 25.2, but here we forgot to write this 0.60. Without that, how we can complete the question? Yes, now just see AW, that is 25.2 into 5 into 0.60. Now calculate this feeder rate of electrode. Then just see the feeder rate is 10.69 millimeter per second. Yes, this is the final answer. Now almost the production questions are completed. Now the teacher of industrial engineering will come, that is Balaraju sir. Thank you very much.
Thank you, Ravi. You're coming to IM and OR. So in total, we have 5 questions. So 3 questions from 2 marks and 2 questions of 1 mark. So, but I could have only 2 questions. So from students, I got only 2 questions. So this question from MRP, Material Requirement Planning. P is a main assembly, and we are supposed to find out the requirement of A. If you see the full question, to produce 10 units of P, how many A's are required? So already we have some stock. So how many units of A available in our hand? 50 units. So net requirement we have to find out. So then how do you proceed? So to produce P, to produce 10 units of P. So to produce 10 units of P, number of units of A required is equal to, then how do we identify the number of units required? So just you see the branches. So A is in this branch and A is in the second branch also. So you can find A in 2 branches. Just you can go through like this. So A to P. So A to P, just you can see their number is 4. So it is understood that to produce 1 P, 4 units of A required. So 4 into, that is for 1 unit, but how many units of P required? 10 units. So 4 into 10 we write. So this branch is getting completed. Okay, so we could complete the first branch. Now coming to this branch, so from here we had A, D, B, P. So take the total path. So A to D, D to B, B to P. So in brackets, whatever number is there, no, that is number of units required. So we can multiply like this, 2 into 3 into 2 into, finally in place of P, instead of 1 we write 10. So what is now plus? So this branch if you take 2 into 3 into 2 into 3 into 2 into 10. So in total this is 40. How much here? 120. So total 160. So 160 units required. But already we have some stock. How many units available? 50 units available. So net requirement is equal to 160 minus 50. So 110 units. So answer is 110 units. That's it, 2 marks question. So very simple. Of course, this question we have covered under expected questions in GATE 2022. Once you go through my video, then you can understand same question I have covered. Next question related to types of inventory. Of course, I have only just some data. So which is not a part of inventory? Finished goods, semi-finished goods, and raw materials. One option was given CNC machine. So CNC machine is not a part of inventory. So types of inventory, generally I start the class like this only: finished goods, semi-finished goods, and raw materials. So these are the major types of inventories. Okay, what is the answer? CNC machine is not the part of inventory. Yeah, so with this I can conclude the session. So before concluding, so my dear young friends, just don't be in like when you have performed well, so people are taking rest. So when you have performed not well, also people are taking rest. So my suggestion is, whether you have performed well or not, so please continue your preparation. Don't get discouraged. Okay, so competitive examination, of course, the paper is tough, means tough to all. So don't worry about that, and it is not the end. Okay, so you have to continue the race. So to win the race, join ACE, and you have to choose only quality resource. And particularly in the market, there are many resources available. So always you have to choose the most relevant and the quality resource. Particularly, you have to see the expertise as well as experience. So both are important. So we have enough experience and enough expertise, and we have a committed faculty. For one subject, only one faculty. Definitely I can claim that my faculty is going to be expert, because we deal with only 1 or 2 subjects. So definitely you can expect expertise. Okay, so don't be in the trap of some marketing strategies. Okay, final, this is as a teacher, it is my duty to tell, so what is good, what is bad. So believe only the good resource, and don't waste the time, and don't waste the energy, don't waste the money. I wish you all the best. To join the race, to win the race, join ACE. I wish you all the best.